Hello,
Okay, I
future
can't make
people.
jokes about Postgres anymore. Okay, so let's go. Let's continue here. So here we are.
And how? What are we
Uh,
doing, Fernando? We are reading uh, uh, the beginnings of documentation that Marinho did that I asked him to do about what are the steps that our system needs to do, and we are doing
yeah,
the distributed database thing.
yeah, and there's actually a couple questions that came up while I was writing this, which are uh, like before this in the file, but
Yeah, we're
those
gonna
are
If
go
this
basically
there.
was a
questions.
company, Marin would have had to have done this on Jira, and he would be happy. You know.
Nah.
Anyway,
If I was
so
the CTO, he would have done in org with Emacs, and that's all I
this
have to say about that.
so word in which files are not chunked. So we're gonna go with this happy path, and then we probably can expand to this. Okay,
Yeah,
so let's
basically
see.
there's basically the transition from one world to the other. We basically
Mhm,
have to add a bunch of three operations in between.
Assuming we do a good job.
Yes.
Okay, so read the file given a file name. So client send a message to the bookkeeper, which is reminder on the architecture, it's the entry point.
Hmm.
To the bookkeeper asking for the current value of the file name. So it's gonna basically open a kind of a file descriptor, right? My understanding. It's gonna say, yeah, this file, like here's the descriptor, you can start writing garbage to it. If it doesn't exist, it's gonna probably create if you marked it to open, right?
This is to read a file actually. To write is the next one.
Yeah, yeah, yeah,
Okay, but if the file doesn't exist, okay, makes sense. If the file doesn't exist, it should error, right?
yeah.
Uh, okay.
Yeah.
And then the bookkeeper says, it okay. It looks up in the current hash associated with the file name. So on the hash table that I don't remember the name,
Hashes, I
we
think we called.
hashes. Okay, so we can get that, and then once we have that hash, we send it back to the client. So that's the hash of the version of the file, right? That's
Yes.
the top of the Merkle tree, the root.
Here we are in the world in which the files are not chunked, so this is just a hash of the file. So
I
it's
have
a
a
bit
question.
simpler.
I have a question. So when the client asks for the bookkeeper for the current value, what is the semantics of that term? Because we are sending a hash back. What is supposed to be a value?
Because here's the thing, the file name refers to a thing that is actually mutable, right? But the things
Mm-hmm.
that we store are immutable and
Yes.
they are referred to by the hashes. So this is basically saying, okay, I have a file name. Tell me the hash of the current version of the file so that I can look up the contents.
So a lookup is a two-step process.
Yes, you need to go from the name to the actual hash that tells you that gives you a signature of the contents, so you can then look up the contents later in an immutable manner because that's not going to change.
Mm-hmm.
Yeah, but couldn't
But
we
We
the
don't have a
name,
problem with transactionality in this case, right?
Yeah, but couldn't we
right?
just assume that when the client is asking a simple question of I want the value of this file, couldn't we just assume it's always the most updated one instead of giving it the hash and the client needs to do another query to the bookkeeper again?
I mean, we could, but then if the client needs to do things that will take time and he only has, here's the thing, if he only has the name of the file as opposed to the hash, and the things that he needs to do, the operations that require him to read the file takes time, the file may be updated in between, and you won't be able to tell because you don't have the hash. You would have to compute it yourself. So now the client needs to know the hashing algorithm that was used to derive the
No, no, no,
hash.
no, 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 no. That's not what I mean. Let's suppose that I ask the bookkeeper, give me the current value of this file. The bookkeeper does the lookup and gets the hash. From that point onwards, if something changes during this time, it doesn't matter. The bookkeeper has
Right.
the hash already.
Well, we could have the bookkeeper talk to the file system and send the files to the client, but then the client will have to pass through the bookkeeper to grab the
Oh,
contents.
so we're not gonna do that. I thought we would. I thought the only entries to the system would be via bookkeepers, but you can actually not talk to them necessarily.
Oh,
Well,
it's
depending on
interesting.
how, yeah, depending on how we set things up, that goes back to the question two above. I basically asked, should the clients only talk to the bookkeeper? Should the clients also talk to the file system? Does it make sense for the clients to know that there's a difference? Here I just did, okay, let's do small atomic steps. These absolutely must happen. We need to look up the hash, and then we need to figure out which file systems have the hash. And then if we decide, okay, the client doesn't talk to the file system, only the bookkeeper, then you just replace the label and say, okay, it's the bookkeeper actually that will do the lookup and tell the file system to grab the file instead of bouncing the hash to the client and having to do a second request.
Yeah. And I'm also concerned about another thing because if we are involving the client knowing hashes and all that stuff, we're gonna the database the client as a database, like, I don't know, Racket Tower or Perplex, we're gonna have to develop in our own databases a system to store Canteen stuff, right? Am I
Right.
correct? Like we're gonna have to make like plugins, Canteen plugins for our databases because now it's not only an API. We need to store stuff that comes from it.
I mean, you would have to store like file names and such. The reason I
No, but
use a hash,
the schema saves the file names, Marin. If I have a
it
car
does.
table, the car
The
is
problem is
also the file name.
the problem is that the file name is actually like it's actually technically a mutable thing in the system because it's a reference and the thing it refers to may change over time.
Yes. But you agree with me then, right? We're gonna have to make plugins for all the databases that want to
Well,
participate.
I mean, wouldn't we need to do that kind of if we were
Mm,
using a normal file system?
Oh, maybe. I don't know. I'm just mentioning this because it's not really plug and play anymore. Because now, in order to entrance the realm of
yeah, you
distributed
need a
database,
protocol,
yeah, no,
The
not
clients
only a
can
protocol,
look,
not only
which you
that.
did already anyway.
No. The
look,
protocol is fine. The protocol is what I'm calling API. You need to save stuff, and maybe you need
look,
to save and remember them in a specific manner.
Look, the client doesn't actually have to be the database directly. The client could be a user space file system, and then the database just writes to the file, and it doesn't need to know that behind the scenes, this is actually talking to a distributed file system.
Yeah, that would be funny though. Imagine, yeah, I'm trying to open my song, and it's in Thailand. You know, it's hilarious.
Well, yeah.
But okay. So we need a protocol which we already have, but we also need a way to. We're gonna have to think about this from a client's perspective. How should I store the data from Canteen? We have hashes. What else are we gonna send to the client? Only hashes?
As far as I get, yes.
Okay.
We just store in a file sequentially on
Yeah,
each
just
node.
hashes and file contents essentially. And in the world in which the files are actually chunked, they are actually Merkle trees.
We just need to save like in our mode, right? I think I already mentioned this with Marinho. Like, we need to save the name of the file that it's on the node, the position like that we start, and how much to read to retrieve this chunk.
Yeah.
Yeah,
It can
basically.
be arbitrary sizes.
Yeah. Okay, so let's continue. After the bookkeeper sends the hash back to the client asks bookkeeper for a list of file systems that are known to have the file associated with the hash. So this is essentially a list of locations, Marin.
Yes.
So now not only hashes, but list of locations the client also will receive. And the bookkeeper look up file systems known to have the file. So this happens before sending back to the client, I imagine. And then send the list to the client. The client select a convenient file system and asks for the contents associated with the hash. The file system uses the hash to find the location, and send it back, and the client is happy. Yeah, this is very straightforward without chunking. Very straightforward.
Yeah, with
Mageta?
chunking, there are additional steps, but that's why.
Mageta, any comments?
Not really. I don't think I.
Okay. Let's now read how the heck you write stuff, which is interesting. So the client sent a message
Okay.
to the bookkeeper containing the file name, position, and payload. Bookkeeper look up current hash of the file name. Look up the file systems known to have the file identified by that hash. So in this pipeline, we don't do two ways. We only do one, which is what I was proposing before.
Yeah, the problem is that in the case of, in the specific case of writing, if the client needs to actually go and talk to the file system to write the new file, we have a slight problem because then the client needs to tell the bookkeeper, hey, there's this new hash that I got from the file system from this writes operation. Update the name to point to it. Do we want the clients to do that? That's another question.
Yeah, no, I understand the problem. So instead of having to do this broadcasting of, hey guys, I have a new hash, the bookkeeper knows because he's the one handling the stuff by from the start.
Yeah, we can mess around with which participants do which specific step and adjust the communication, but this is basically the rough timeline of what has to happen. So,
Yeah. Okay, so then the
What you're
book.
calling file system is like the. Well, it's gonna be also physically on the same node, but it's the other logical part, right?
Yeah, Marin was using the names from the structs that we made.
yes, I am.
Yeah.
Okay, it's the other daemon in this
Yeah.
case.
So the bookkeeper look
Daemon
up
or
file
demon?
systems. Look up file systems known to have the file identified by that hash. Ask file system to write a file using the hash as a starting point, given the position and payload. The file system copy file identified by the hash to a new location. Copy the file identified by the hash to a new location. Oh, this is because
Yes,
it's immutable. We not
Why do we
overwrite
need
stuff
to copy?
because we're not mutating it. We're not changing the thing that there are the things
Okay,
that are
but you
there.
can just save the thing that's incoming somewhere else, no?
But
we,
wouldn't that evaluate to a new hash, Mageta? If you just change part of it?
You just need to. Well, on write. So here's the problem. On writing. Okay. The problem is that we're mistaking two things here. I think there is the hash position in the file, right? That's location,
Mm-hmm.
and the second hash should be derived out of the block of the write.
Mm-hmm.
So when you are writing, you're giving the reference of the block to write to, but you shouldn't be able to write exactly on that position because the hash that you're gonna get as output is different.
yes,
So the bookkeeper gets the data. So the flow will be like this: bookkeeper gets the data with the hash and the data, the binary, and then he sends to the file system and says, "Write this garbage here, where it was supposed to be." And then he does all the linking, like for the new structure, right? It appends on the file, writes it under another hash, but then it just says, okay, where it was this guy, put this guy now on this new version of the file, run everything on the Merkle tree, and then you now have a new structure of the tree with this file. But you also have the old one. You see, nothing changed in place in the disk. You just appended.
Wait, I didn't get how you're maintaining both because you said writing it at that position without copying it first.
So okay, when it's I'll go again, but I'll explain the parts by pieces. So when it comes to the bookkeeper, the first time, you're gonna write and it's gonna replace a position. Our thing is append only, right? So we can only append, never remove or replace, overwrite, right? We don't do that.
Yeah.
So we append to the end of the file, and then when we hash on the client the block, it's gonna give you a new hash, right?
Yeah.
Now you
Yes,
have two
because
hashes.
yeah,
One is derived out of the old block, and another is derived out of the new block of info. So far?
No,
yes.
but yeah, but here's the my question. Let's suppose that at the position that you're writing, there was
Mm.
already data there.
Yeah. What's the problem?
So my understanding is that Marinho proposed to copy the file because in the copy we will change from this position onwards the contents
I
with the
understood
payload.
copying the structure of the tree, not the file.
This is the world
Ooh,
where the things are not chunked. So actually, this is the entire file.
yeah,
Yeah, it's
right?
the structure. Yeah.
Yeah. So in your example, you said we're gonna append the new data at the end of the file, but
Yes.
isn't that not following the position parameter at all?
You're mistaking the physical arrangement with how things are represented.
I'm
The when you're
confusing
writing, when you
arrangement.
give a hash, it doesn't matter if it's the first, if it's the last, or if it is the same position as it was. What matters is that on the structure of the tree, you should copy it and then just replace on this new copy the hash with the new hash of the insert that you just did.
Oh, so the tree has the position taken into account, but in reality, we are just appending crap.
Yes, and the tree, and then we are going to have the list of the hashes saying, okay, this hash now points to this position, but you still have the old one. It's still there.
Oh man, but I
It's
don't know how to
more, that sounds
evaluate.
harder than it actually is, I think. This is not that complicated.
Yeah, no, but that's what I'm thinking. Like, is that we're gonna have to do something because we need to retrieve the data, right? And we have the tree mimicking something that is not written on the disk actually, because in the disk we are only appending stuff. So we're gonna have to do something
The
about
tree is
that.
just saving hashes and linking the structure. That's it.
No, no, I understand that, but let's suppose that I'm reading the file, right? I'm reading the file. Now we go
Mm.
back to the previous bullet point list, and the bookkeeper is supposed to send me the hash of that file name. So let's suppose there are two hashes of the same file because it got updated recently. I will get the latest hash, let's suppose, and then I'm
Mm.
gonna talk to the file system as the client, and the file system will do the hash to find the location of the file on disk according to the bullet point there. How are we gonna know?
No, no, no. Wait. If you are okay, let's go back again. When you are writing, you're gonna send the hash as you want to replace, right? So
Yeah, basically say, here's the old file, here's the position in the file and the data that I want to write at that position. Make a new file for me.
yeah, the position is the hash, right? In this case, so
No, the
it's
position is literally the offset from the beginning of the file. The hash
That's
is
what I
like,
understood.
yeah, so the hash is like, okay, here's the original file. The position is, okay, here's where in the file I want to change.
okay,
And then the
okay. That
payload is just,
works. Like, yeah,
yeah,
that's just adding a new layer right here. Just gonna do like a seek, basically.
basically, yeah.
Yeah.
Yeah, but man, that makes a little bit more complicated, but this is still the same flow, right? Regardless.
No, 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 but I still don't understand. How are we gonna get from a hash? How are we gonna know that, man, because we just appended crap, they are not copies of the files with the correct data there. We just appended. How are we gonna know that we appended? How much you're gonna have to jump in reality when reading the disk itself?
All the three, like, well, let me share my Emacs.
Like I know this is confusing as fuck, but I'm assuming that you understood my question and my question is not stupid.
Yeah. So here, so your question is physically, like in a normal Unix garbage, you have the files, like the chunks of the file, right? So I'll represent as a list.
Mhm.
So you have the first chunk that is, I don't know, this is like the data. Okay, so 1, 2, 3 is written here, and then you have 4, 6, 8 written here, and then you're gonna have well, let me copy this and paste it here. See, yeah. So 4, 5, 6, 7, 8. I think that's enough.
Mm-hmm.
And then let's mix things up here. So let's put 1, 3, and then there is like
True 5.
7. No, I'll put 8, then 7, 2, 5, and what else is lacking? This. Right? So they actually are the same thing, but the only difference is that the last one is all mixed up, right?
Mm-hmm.
So the only thing that will change here is, think of this. Here you can, the offset already represents exactly how it is physically written, right? So you put the offset on 0 and you go reading until the end of the file, and then you're gonna get 1, 2, 3, 4, 5, 6, 7, 8. All these blocks in order. If you do the same here, supposing that you're gonna read uh, things in a sequence, right? Uh, I'll put even something like, okay, this is for file A, okay? Oops. In this case, it's all for the file A, okay? So that's why I put it there.
Mm-hmm.
In this case here, these are for file A, but this here is file B.
That's okay.
So what's the problem now? Think of this. If you put the offset here and you start reading physically the file, you're gonna get 1, 3, 8, 1, 2, 7, 2, 5, 4. That makes no sense, right? You're not only getting things scrambled, but you're also getting things for a different file,
Yeah, but
right? So,
I thought that would not be possible. Like why would we add chunks of data from different files continuously?
well, because there is no reason why we couldn't, because we're gonna access is that we're gonna have a hash table that stores the locations. Do you remember that?
Wait a
And then the
moment.
location will say, okay, hash blah blah blah, so hash one, whatever. It's on this position in this file and it has this length. And then you go there and then you pick the entire record and then you know exactly where it starts, exactly where it ends, and then you can like you can do a surgery on it, pick it out, or read it, whatever you want to do. Well, you can just do anything, right? You can just read. But you got the point. Like you just go there and you look at it and then you can read that position particularly. And then how do you know like how to follow an order? Because the hashes they should be aligned in the hash, they should be sorted, right, by position of the insertion. And then it will know that this guy here is on this position, like 0, let's say. Then we go there, pick the length, and say, okay, this is the 0. It's the offset 0. And then it ends at a certain offset. And then you say, okay, where do I continue with this offset? Well, you continue this offset on 2, which is this other hash here, this position, this physical position on the disk. You see? So you gotta have this intermediary structure that does the translation between both parts.
Yeah, yeah,
So
yeah.
a
But I think now that I understand what you meant, Marinho, I think Marighetta was having a completely different design in mind than what you wrote, I think.
didn't notice it was, to be honest.
Because,
But
for
what
instance,
changes here essentially is one of like we're gonna have to translate the len of a to a file that has offsets in this order, len of a plus b. You see?
yes.
So this will be the amount of things we can read from one file if it's like this, and this is the amount we're gonna read from there.
Yeah,
Well,
I think
technically,
Marinho was assuming that we would not have files with contents of A and B. A file A would only have contents of A, and a file B only contents of B.
I don't think it matters much, man,
No, it
because
matters because now we need to do all of these intermediaries thing that you said to jump the B there because we want only A content.
even if you were not doing mixed up, you would still have to do that.
Really? I don't
Oh,
think so.
like here's the thing, man. Why should the physical representation on the disk matter for the underlying system? It shouldn't. So from Marino's standpoint of view, like the functions, the routines he was describing, that shouldn't affect anything so long as we do this, right? We translate this. I mean, like
Uh,
even if we don't have this, because then you are assuming like you're just gonna replace positions or copy the entire file. There are only two options.
which is what Marinho described with copy the file, I believe.
So you would copy. Okay, so it
Yeah,
would be like this, and then you would copy everything,
And then you know that you're gonna change the 4 in there,
and
and
then
then
you change the four, and you wanna delete it, let's say, and then you delete
yeah,
it.
yeah, and then the hash of the first one would be different than the hash of the second, and that's how
Yes.
you do the versioning
Yeah. That's
essentially.
simpler, but if you have like a 1 petabyte file, you're copying one
Yeah, that's
petabyte file.
exactly where my mind went. What if you have the chunk for some random reason is a petabyte?
You
yeah,
Then
change
I
and that's
one
think
why
character, you gotta do it all again.
yeah, and that's why I said we will probably do chunking because large files are a problem if you don't.
yeah, but now we gotta decide. Are we good? Because I think Marinho's way is easier to implement because it involves less moving parts. Uh,
The way I described is just without chunking, which is like it's basically gonna fail if we ever have a file that's a petabyte large because you would have to copy the entire thing, the entire petabyte, change a single byte somewhere in the middle. That doesn't
That's
scale,
good.
is the
That's
point.
good. What do you mean? You just need event sourcing and it will scale. Don't worry, man. You're gonna have more metadata than actually data. Don't worry.
It
okay.
reminds me of a conversation I had a long time ago with my father, where I was talking. Uh, Basically, he asked me why didn't I learn C first, and I said, "Man, I don't wanna, I don't wanna start my programming learning by learning about memory management because that's hard. I wanna learn about, actual computation." And then he said, but if you do object-oriented programming, you don't need to worry about memory management. And I was like, WTF?
I mean, if you
WTF.
close your eyes, you maybe you wouldn't think of that, man.
Yeah, yeah,
Just
yeah.
close
But
your eyes.
anyway, Marinho, do you think we should go with even without chunking with Mageta's way first because it scales?
It scales.
Well, it scales better than copying a petabyte.
I
No,
just
but
do
here's the
see it
thing.
substantially harder not to go with that. That's my.
Well, yeah, maybe I am overestimating it, but it sounded substantially harder to me.
Here's the thing. What Magetta was describing, I don't really know too much about append-only file systems. Like BTRFS, I think is one of them. There's ZFS as well. I'm not familiar with their inner workings, so I'm guessing that what Magetta is describing is kind of similar to what they do. In which case, yeah, we can get
If I am getting that right, I have no idea because I'm an idiot.
But that's the fun part. If we rediscover something this hard, we are doing great because we did it without knowing
Or maybe other
uh,
people discover something dumb. Who knows?
it.
anyways, I actually don't know if that's what he was describing or not. If it
Yeah.
is, then sure, we can probably get away with no chunking on the logical layer because the file system does it for us. But I think actually doing chunking would be
Right. There's something extra to consider, right? Because these things here, let's see, these things here, they are like the hashes, right? So they can be arbitrary sizes each.
well, no, a hash by definition has a fixed size. Otherwise, the function,
No, no, no.
well,
I meant the content of it, right?
I see, I see. Yeah.
So yeah, that might be hard to chunk. Like we still have to chunk stuff, right? Regardless, because well, you can send the data into like what? Well, depends on. Actually, no. Wait, that one wouldn't be that much hard because think of this: if we put like 64 kilobytes, which maybe is a lot, right? But let's suppose we go with that 4 kilobytes, whatever, uh, as buffers, right? Each chunk is 4 KB. Let's suppose we set that, and then you send 8. You should break it in two, right, to write it. On the return, we should give the hashes to the user so they know what changed, right? What you actually wrote. Because remember, who has the control is only the file system that does the hashing of the data,
Yeah.
right? And then it would return, instead of one, it returns two, right? It returns two hashes, and they are written
Actually,
subsequently, appending.
that's where the Merkle tree would come in, because instead of returning two hashes and then having the client deal with the fact that he may get an arbitrarily long list of hashes, we take those two hashes, we build a tree node, which is another chunk to store in the file system. We hash the tree node, and now we have a single hash, and we send that to the client.
Okay, so you want to make a oh man, you want to make an intermediary hash to hash the hashes.
To hash the hashes.
Oh boy.
Yeah, but don't you guys think that maybe we are going a little bit too far in terms of like I think we should try to implement what Marinho said first, and then when that's working, then we improve upon it because I think right now we don't actually completely understand the consequences of changing the step-by-step process that Marinho wrote. So maybe we are shooting ourselves in the foot by changing to a maybe more scalable and more usable stuff. But I don't know if well, at least I can only speak
Like I
for
don't like the
myself.
term scalable because that diverts the intent from the design to be like, yeah, performance. I want to increase performance, which it does, but that's not the point, right? I just want to highlight this.
Maybe I should define what I mean with this term. So I mean that when I say scalable, I mean that the abstraction fits with an arbitrarily sized amount of stuff, whatever that may be. So
Mm,
let me give you an example. Do you remember the data structure hack that we did
yeah, I see. Like
for Lithium?
it's generic. That's a way to say it's generic
Yeah,
enough to cover a larger set.
yeah, arbitrarily large, which is big deal. Because for instance, you just mentioned that the this copy process that Marinho suggested in the bullet points, it doesn't scale with 5 petabyte files, right?
It doesn't.
It doesn't. In your way of mixing matching the A's and the B's there, and having to do an intermediary thing, that seems like it does with 5
You
petabytes.
just have to manage now different files on each client. That's one thing.
On each node,
Like
you mean?
yeah, like each node will have pieces of the same file written, right? Replicated.
Yes,
Yes.
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 That's the only difference. I was thinking of writing only one file per data thing, or you can actually write multiple, right? As long as you control the size of each. Like yeah, when it gets to like 1 GB, I stop writing on this file and I write on another. You see, like, and then you
Yes.
just go
Yes.
in this.
Uh, but I can only speak for myself. But I think if we implement the process that Marinho described first, we're gonna have an easier time changing the little pieces because now we have an entire pipeline that works.
Okay, so let's dive. Let's do a deep dive on the code already. Let me explain what I was doing, and then I'll throw at you, Lemos, because I want to see you suffering, because I suffered with this.
What
So
a friend.
what I was trying to do here is trying to start writing to like a temp uh, directory, uh, just just to test the writing the file, like the entire flow. Right, right now we are halting the thread whenever we receive the information, we process it, and then kills the thread. Right, it dies. So I was trying to use, oh sorry, not thread. It kills the server, the socket, right? Because it finishes whatever it has to do, and then it kills the program, right?
Yeah.
Ends the flow. So I was trying to do a loop based uh, garbage that basically keeps creating a thread that shouldn't be recreated all the time, and that's what my difficulty was.
So,
That we fork as a thread to handle the uh, spawn of the uh, socket. You see, so but that's still incorrect. So that's where my problem becomes. So let me explain what I wrote, and then I'll show the problem. So
wait a moment first. What is the function loop supposed to do?
yeah, I'll get there.
Everything else I
So
think makes sense. I don't know
no, man,
about you,
it's
Marin.
no, nothing here makes sense. That's the problem.
No, I read all of it already. I think I understood your
Man,
idea.
I was changing this garbage, and it was working to some degree, and then I started to change just to see what I was doing, and I noticed it all wrong. I'll explain what.
Okay, go.
The I'll start with this. So this just basically sees if the directory exists. So is this a directory? If so, then you don't need to create it. Otherwise, you create it. If by doing this the directory doesn't uh, like there might be a file, right? But supposing that it's not, it's gonna throw an exception, and then I
Yeah.
capture here, and then I create the file anyway, the folder. So who cares? And then I call this garbage here, assure directory.
Mhm.
So that's it. Uh, the next thing that I do is that I make a buffer, and this is the thing. The man, this is the devil because
I need to stop you right there.
man,
Uh,
I okay, but I didn't
uh,
explain anything.
yeah, I know, but I want you to remember to remind me. I noticed that the run receives unit, and it after the equals you have a parenthesis. What is this again? Are we doing a
Uh,
tuple?
you mean this?
Yeah. What is it
Oh,
supposed to be
this
that?
is yeah, this is SML's garbage way of doing begin. So this is like if you have
Oh.
multiple. So if you have multiple expressions, instead of like doing begin end as you would do in Okamo or F sharp, this is the block.
I
So
like F sharp.
why is this?
That's fair. No,
Yeah,
now
they
you can
remove
continue.
this on F sharp and put indentation based, which I think is cursed. But anyway, the since we have multiple expressions that return unit, we have to put the semicolon, right? And then we put with this thing here because of the let structure.
Okay, go
Like
on.
in
Explain the
translating
devil.
to F sharp, this would be like a do. You can even put a do here, or you just don't do anything, and that's it. Since it returns unit, it ignores. If you return something, you pipe to ignore. Ignore whatever. So anyway, so that's it. So it would ensure the directory is created, right? This garbage here, and then it says, okay, uh, create for me a reference for this buffer that will hold an empty string for now,
Yes, I
and
remember that.
this is going to be our communication thingy to send over to the socket, and then when the socket is done, it's gonna write all the bytes that he received over the network to this guy, and then we're gonna use that with the uh, what's the name? The deserialization functions we did,
Yes,
namely this here, to
remember
convert
that.
it back to a command, right? So we
Remember
convert
that.
the
Yes.
yeah, we split the bytes, do all the stuff there. Uh, and then okay, so end of transmission is 4, so we pass it there. You can ignore this. This is commented, but in my mode this is still not showing it. Comments. And wait a second. Okay, I just thought production was exploding at work. Uh, so it's just been a meeting at 9:41
Yeah.
in a Wednesday,
Yeah.
normal day.
Normal day.
So okay, I did this spawner. So this is spawner is basically a function, like it's just making it lazy, the creation of the
Mhm. Mhm.
spawning the socket, right? So I send this receive unto you, blah blah blah, which is the handler, right? So we're overloading it with uh, the character we wanted to stop reading by. The buffer it should write true, and the last argument is the socket, if you remember. I don't know if it shows here.
Yeah.
Does it?
No. No, I remember
It
this
does.
one. I remember this
Yeah,
guy.
it picks the socket later. So and then it returns the the communication handle action, which is either continue or stop, right? I think stop.
Yeah.
Uh, and then we pass the port and the pooling. That means like the amount of garbage that should be you should try to listen at once. Uh, the problem of this is if I spawn this here just now, it will lock the program. So I don't want to do that. I want to keep looping, right? Um, so what I want to do is send this garbage to a thread, and then the thread does this to me. Or I can, or what I can do is that I send to this spawn. Let's go there. This spawn it does this.
I also
Do
remember
you
this.
do you see this?
Yes, I see this. And I think I
So
redid in a continuation pass style this thing. We keep passing handlers and functions and keep going, keep going. That's why I propose using a mutable buffer, right? Because it's easier.
yeah, that's the problem to do here, which is pain. But anyway, let's get there. So we pass this accept, which is this guy, right? That's trying to basically accept a message, and then it keeps. You can see what I was doing. I was going insane already.
Blood.
Uh, and then you can try to. What it keeps doing is that it keeps trying. Oh yes, I was just testing to see if it printed. Um, what we need to do is basically try to do here the deserialization, and because this would be the thread, right? So when you accept a thing, so here you would keep accepting sockets, right?
Mhm.
So you shouldn't just die, right? You should, that's why this loop here it continues whatever, right?
Yeah.
So it keeps looping over to this accept again with this handler and so on. So this is already naturally a loop. What I
Yeah.
intended to do here was to, okay, I accepted a thing, I'll open a thread, send this handler to be executed there, and then it does whatever it needs to do, like communication with all the other stuff, and when it finishes, I just close the connection, and that's it.
Mhm.
So to me, that's what it should be doing, and that's what I think we should continue, because once we have this, we can already do the uh, do the search, right, of the tree. Oh, we need to redo the structure of the tree, right? That's one thing we need to do. And then we can start using the hash tables to identify the locations and all of that.
Mhm.
So we can write to the file and the positions we want while storing the structure, the hashes with the locations correctly.
Okay, so I'm gonna try to ask you a question paraphrasing to see if I got it.
Mm-hmm.
So what you want to do is you want to spawn a thread, keep listening with this
Keep
spawn accept
keep
stuff.
keep accepting, spawn the thread,
Yeah.
and you invert it.
And
But go
then
on.
you read everything that you need, and then you close it, and then you're gonna.
No,
Oh
no,
yeah.
no. You read everything you need. This handler will die, right, eventually.
Yes.
And then you deserialize. So something like this. You deserialize it. You see?
Yes.
And then you can do whatever, and then this thing can communicate because it would still have the socket, remember? And then it can still send a message, and then when it finishes executing this, it will get out of the thread, go to the accept again, emit a stop, and then it would halt, close the. Uh, well, actually, we should close here, right? Should close the socket already. If that's the case, we shouldn't close here. Yeah, like
Mm,
depends on the control flow, right? If we need, what I'm saying is that depending on the message, you need to give a response to the user, right? If it's a read, you need to perform the read and then give the answer, right? You just don't close it and do the task. That makes no sense.
I see.
Ah,
And what is not working about this then?
well, everything. So I
I,
got it working at some point, but
I'm
then I
fairly
don't know what I
certain that
did.
we made this work last session
We did, but without the threads and all this craze,
without the
which is the
threads.
problem.
Yeah, but didn't we also didn't we also say that when we added threads, the mutable buffer thing will not work at all?
So yeah, because we need the mutex. So what I
Yeah.
wanted to do is delegate this
Hashtag
responsibility.
SMLSTM,
That's
please.
why I want to do everything inside of here, because then you don't leak the buffer outside, right? We're just leaking the buffer outside because where it's actually coming from whoever is spawning it. You see?
That's true.
Because we need to pass this damn handler here. So if we do it inside of that, it will still mutate, but it mutates uh, inside of the scope we care about, right? Not on the other thing that's gonna close and die. So that's it. So that's it, Lemus. Good luck. I will. So we can now pick the screen, and I will be right back.
What a friend. Uh,
Amazing.
sure. Okay, I'm gonna. The screen is now black on the stream because, well, I was not prepared to suddenly drive. Let me open my stuff.
That was a very classic okay, thanks, bye.
Good, no, no, it was not because he even said good luck. uh, he even said good luck. Which branch Magetta is working in? Do you know, Marinho?
I think it's data nodes bootstrap or something like that. And do git branch.
Let me remove some stuff. Does not match any files. Okay. Git fetch. I'm gonna put. I need to remember to put stuff. So which one? The bootstrap.
Yeah, I
Fernando
think it's
said about F sharp, and as much as I'm tired of just typing F sharp every day, and I type like what 1,000 lines per day.
Wait, you work with F sharp?
Yeah,
Yes.
for what now? 4 years, I think.
Where?
No, he
I
can talk about with that with you later.
yeah. Let's talk about this later. But
Okay.
uh, it's a second company,
Yeah.
and I like the language, but I don't like people using it. That's
Like
the problem.
I just
You don't
imagine
like me.
I just
No,
imagine
no, it's
Magetta
not
being
about you. It's
the
like people
biggest
mis.
Chad. I like the language. I
It's
don't like people. Period.
yes, yes, yes,
Talk to computers only.
yeah. Man, I don't like how people use it. It's very cringe.
That would be hilarious.
That's better than people using Okamo though. But well, actually, that's better than Okamo. Period.
Ooh, that's a hot take.
Dun, dun, dun. Well, Kamalers won't watch this. If they do, they can screech.
Okay, so I'm ready. So I need to. Oh, I'm not ready. I need to spawn Emacs from here because it's supposed to give me LSP. Although I don't know about that. Okay, I am ready. So now the screen can go back on. Yes. Where is the file that you just showed us here?
Wait, which file? The one, yes, the one that it does the entries down there. So go down. All this,
Here.
yeah, the run.
Uh, are you sure?
Uh, I think you didn't pick the branch, did you?
Which branch are you using?
Bookkeeper,
Oh, that's
which
why.
we should merge, by the way.
Um, so there
This
is a branch called
garbanjo.
Bookkeeper.
Yeah, I think so, isn't
Are
it?
you sure?
Wait, I might be daydreaming. Just a sec.
Let me do a git pull.
Sonhar, sonhar, poder fugir. E pra onde foi, além do mar.
Git
Estamos indo
fetch.
e mudar de cor.
Are you sure there's a Bookkeeper branch?
I didn't commit. Oh
Oh,
man, then
that
they would make
explains it.
fun of me. I
That
know.
explains it.
Yeah, let me commit. It's garbage, but I'll commit anyway. Garbage.
And I still have to understand what exactly is not working about it.
There. Yeah, you will run and you will see.
Uh,
There. Just fetch and look at the commit name, by the way.
look at the commit. Mageta, Mageta, Mageta. Are you sure?
Yeah, you're not. Wait, the branch is the
I
branch
think
is
I am in.
bootstrap nodes, bootstrap
Yeah,
data nodes. Yes.
yeah, I think so. But this is still not giving me the
Do a
things.
revert buffer, Unimax.
Revert.
Yes.
Yes. It's still the same
What?
thing.
Huh?
Like, am I
Are you on the
daydreaming?
right
Let's try.
branch? Yeah, maybe you just
Oh,
didn't.
I
Yeah,
just fetched it.
yeah,
That's why.
just fetch. Yes, just fetch. Let's go.
Yes. Okay, now I
There
have
we
the
go.
stuff. Now I have the stuff.
Yeah, now you suffer.
Okay, so what is the thing again?
Nix run dot slash dot slash no hashtag yeah execute I think. Oh, we have a just file for this, don't we? Yeah, that's what it does. I know.
we do have a just file, just run. Cool. Um, so have you debugged this at all? Do we have an hypothesis of what's
So
going
here's
wrong?
yeah, it's not looping. So let's go by thing by thing. Why am I coughing now? Um, let's just start fixing crap right away. So delete the buffer.
Oh, okay.
Let's go bold. Uh,
So this also needs to vanish.
yeah, but you gotta change the signature
That's
now.
fine. Where is that here? Buffer.
Communication, yeah.
Yes, here. No buffer for
Uh,
you anymore.
yeah. Bye bye.
Where is the buffer being used? Here.
Bye bye. Yeah. Oh, actually, the receive and chew should have a buffer, right? What shouldn't have the buffer is the thing down there. This should be curried regardless. No,
So
no,
I'm
no,
gonna
no,
copy
no, no, no,
this.
no. You, yeah, you delete it from the file on the right, but you keep on the left.
Yes.
No, Lemus.
You keep it on the left. You just said it.
You're gonna keep loop. Oh no, this has an internal loop, so you can write there.
Yes,
Never mind.
exactly. Okay, this is saved now, which is cool.
Oh,
This is
so then you don't need the what can I say? The buffer. You can just make a variable.
that is true in fact, actually.
You don't need to
Oh, no,
mutate.
no,
Just
no. We
do
do. I remember why we did this. It's because we cannot return. We cannot return the loop empty string. We need to return continue. In the way that we are passing this value forward was via mutation. That's why we did it
no
like
man.
this.
Yes, that's why we did it before, but now we don't. We are gonna return the buffer.
Oh, so we're not gonna return continue anymore. We're gonna
Yeah,
return the
who cares
buffer.
for this crap?
We're not gonna close the socket that you
Yeah.
said also, right?
So let's think. Depends on the operation, right? But it shouldn't be the duty of this receive and chew to close it. So no.
So this and this.
Yeah.
Here's the problem.
So
Uh,
go
the,
down,
go down.
delete the buffer from the
Buffer.
handler. Wait.
Where is my buffer?
So the handler is being okay. I see. Okay, so add on the handler annotation. Add a buffer. Actually, no. Sorry. Wait.
Like I said, we didn't have to do this back in the day because we were doing partial application stuff.
Yes, but we're the buffer is inside of it, so those doesn't matter. Now the handler.
I actually don't
Ah.
even need this anymore.
So here's the gotcha, right? The receive until it should give you a like go to the handle action due up there. Yeah, you see there on the stop continue. Put like a do like a okay, and then off, and then string, whatever. Yeah,
Off string.
actually in standard ML, it's everything all caps on the thing, like a enum. Yeah, and you can delete the other two, like the stop and the continue. We're not gonna support them. Yeah, and then you just wrap the loop on that. Okay,
We just wrap the loop on that.
line
Oh, here.
34. Yeah,
What is the proper way of doing that?
okay, and then parentheses because
Parentheses.
you're at the application. Okay, so and now on the handler you put okay instead of the stop.
Okay.
and then you pick the value,
So str.
and then we can do the garbaggio. So right. So then at that point,
Wait a
we
moment.
should what?
Why do we need an
Oh,
ADT with only one case?
because here, okay, I'm questioning this design too, but for other reasons. Because different operations they should have different behaviors, right? That's what's the idea. But here's what I'm thinking: you can't just accept the you can just pick the thing and throw it back. You need to know how to behave, right? In our case, we're gonna behave by deserializing this thing and launching a new thread and deserializing and doing whatever, right?
Mm-hmm.
So we can do this part synchronously, or we can do it asynchronously via a thread, whichever you prefer. In
I
my
think doing
judgment,
synchronously is easier usually.
yes, it is. But in my judgment, the correct design here should be you accept the socket, and then the handler you will spawn in a thread, and then the handler would be it would be this case, it would execute whatever it needs to, uh, and in the end it would call another function that is the deserialize and handle all the stuff for us, you see. And then the accept will literally just do one thing, which is what you should do: accept requests and spawn threads for them. That's it.
I think I'm gonna go with your choice because I'm not seeing it right now and I want to see it.
Okay, so on line 39, after that, on the in, like line 40 actually,
I'm gonna
yeah,
do a
you're
val.
gonna you're gonna delete like basically line 41 to 43. We're gonna do that later. Yeah, just comment it for now. Yeah. And then you do in.
In.
Actually, we need to create the thread
Yeah, that's
first.
what I
So you
thought. So
see
I need
on
to
the
do.
file on the right, you need to create the tag for the thread. So val thread equals thread
And what
dot
the heck is going
thread.
on there? Thread dot
Yeah,
thread.
because it's the module and then the type, right? And then fork, and
Yeah.
then you pass the function that you're gonna fork, and then it needs to be a function that
Bleh.
you it needs to be you send unit and you give unit. You see, so you need to make a new function like a closure.
We already have a function. It's called bleh.
No, here's the thing: you don't have a closure. So do a new function inside. Before this, do a fun. Ah man, this indentation is drives me insane.
uh,
And then you're gonna do like handler, whatever. Oh, handler is already used.
Handler is already
Uh,
used. I'm gonna call it. What did you call it?
spawner. I don't know.
Closure.
Closure. Yeah. Don't put a J there, please. And then you're gonna do is do the case, like do a case.
uh,
The second argument is the list of arguments for the function. By the way, if you need to pass any.
I see.
And then you pass the handler. You call the handler. Yeah, it's this code. Almost, it's called almost this. Actually.
Uh huh. Uh huh.
Okay. Uh, let me think. And then if we get it, there's no continue, so yeah. And then what we're gonna do is we're gonna call the deserialize.
Aren't you
That is
gonna
guy
just do
back.
bleh? Like literally this?
Well, we can start simple. So just do a print hello. Yeah, just do blah
Okay. Oops.
blue. Yeah. And then what we do is that this function takes care of closing. So uh, since you are inside the off, put a open before the blah, open close parentheses.
Before the bleh, open close parenthesis.
No,
Oh,
before the
before.
blah. Yeah, because you need to make a scope. No, but I mean the blah
Oh,
goes inside of
here.
it. Yeah, so you're gonna print, right?
Mm-hmm.
And then after this, you're gonna close the socket.
Which the with the code that I don't have anymore. How cool.
Socket dot close.
Socket close
And then you pass the
serve.
S. You pass the S.
Oh, S. S. Yes.
Yeah, because it will be leaving in this
Mm-hmm.
closure. Uh,
I
and
have.
I think that should be it.
Yeah. No, we have still to spawn the thread, but I have another question. I still don't understand why we are making an ADT with only one case? Why can't this just be a string for now?
Because this is the action that we are expecting of the receive until. I just put OK because I couldn't think of a name, but the behavior would change depending on the function you're getting, right? So in this case, you can delete it. It's kind of like bogus because we just have a thing. Like
Okay.
just delete it for now. That's like a premature optimization. We don't care.
I agree with that.
I have a counter question.
Go.
Why would you make a new type in Haskell?
Dun dun.
Well, because you make a new type instead of a data type because there's optimizations if you have only one thing in there. Like the difference between data and new type is because this is only a record with only one element, and there's some optimizations things going on with that. And here you can have records with many things. Right. That's the difference.
The point
Which
I
is
was
also
trying
a
to
function,
make
right?
is why would you want to make a data type with only one element, which would then lead to having new types as an optimization?
Well,
Oh, I
because
think I
go on.
think I would answer this as a modeling point of view, right? Even if you take a performance hit, I would do that just for modeling reasons.
No, and not only
Like,
that, Marinho is completely discarding when you want to make a type, and the type is a function, right?
like when
I'm
I
not
here's
discarding anything. I'm just asking the question because you said, Magetta, why would we make a type with only one constructor containing
A
only one
data,
thing?
a union, not a union, a sum type, a sum type. I don't see why you would make a sum type
oh
only
I
for
see.
having the tag. Aside from documentation and modeling, aside from that.
Yeah, for example, I did on a encapsulation, right, in F sharp, for example. I remember doing a DTO layer that I
Hmm.
think you even coded there, Lemons, if I'm not mistaken.
Yeah, I remember doing
Uh,
DTO.
and then it was based on Scott Washling's book, right?
I read
But
the book.
I yeah, so you recall that he talks about like encapsulating the things in
Yeah,
modules, blah
yeah,
blah.
yeah, yeah.
So uh, I like whenever I do a domain in F sharp, I do that because if I don't like to use the although like the types now the classes I'm talking about they're better. I prefer to use the modules because they're just that's their purpose, right? The damn purpose of a module in ML in meta language is to already uh, express the implementation and exposition. It should be an interface as a given.
Hmm.
So uh, the whole point of it would be to like how it's being used, right? Is to cast down constraints as you go uh, in the downstream layers of the modeling. So, for example,
Yeah.
one way to use a single DU, right, a union. Uh, you have a module that has the same name as the tag you're going to be using in a DU, like that is a function that you can apply, and then you just have a nice API because everything follows a consistent nomenclature, but they behave in different ways considering the scope they are. You see?
Hmm.
So that's one example to make better APIs.
Yeah. And just for the record, Marinho, the paper that I was showing you before, it uses this. I will show you guys the paper later anyway, when it's done. But it uses this, and that's why you make a new type, because this is very specific. Anyway.
But a new type is basically the same thing as a data type with only a single case, and the case contains only a single value, right?
And it has this, how can I say? If you're not doing gadgets, like GADTs, the new type provides you like a natural unwrapper, you know? I don't know how to explain this, man.
I find it weird that in Haskell the generic types they don't have any they don't have any distinguishing feature. They're just like a letter after the type.
Oh yeah, they don't have angle brackets or anything like that. Anyway, anyway. My case was specific about making a sum type, Marin. That I should be more specific. A sum
But
type with
uh,
only one tag. You don't have
but a
values
new
being
type is
carried.
but a new type is essentially that, isn't it?
But it gives you that nice internal function. It's very useful to have that. This thing, right?
But you
Uh,
can get that with a data type as well if you just declare it as
no,
a
you
record type.
can, and then you unwrap the constructor. I know what you're talking about, but it's just more convenient. You see, you can do the same with a data type. You can.
Yeah, that's not really the point I was making when I asked the question, but okay.
No, I think I saw your question. You're just like you can. There's no problem in having a type with only a single case, and I agree, but not that very simple sum type. That's what I got confused because the OK that we were doing with the string, it was not adding anything because this is the only like what is the OK supposed to mean in this case? We cannot fail, you know. That's what I meant. Uh, which reminds me, we need to do a let now. And then we just do this,
Yeah.
and then we
need
just do
let.
that.
We need let. And I think this. Oh, you forgot the val.
The val. Oh yes, I
Let
forgot the
val.
val.
And that's it.
There's an in loose here.
Yeah, that was the in of the first thing. So you need to now call the. So here's the gotcha. Uh, okay, so in and then accept handler, and then you just keep looping forever, and then pray that this thread will die someday.
Uh, pray that this thread will die someday.
Everything dies eventually. No need to pray.
Okay. Do we need to pass? We need to pass the serve again,
Mm.
like serve. Yeah. Otherwise, it's just yeah. And that's it. Ta-da! Let's see if it runs.
41. Syntax error.
Oh, in. You forgot the in of this. Oh, I
Did
forgot
I?
the end actually.
Oh,
End.
the end. You mean here?
Ah, man, this drives me insane.
Calm down, Mageta. Calm down.
Man, people who
This
do these are actually evil. Like, they have this fury.
evil. 41. And expected but val was found.
Wow.
I think
Oh,
it's
there's the
complaining
other
about
in.
this.
Line 40. There's an in there. You forgot the end.
Oh, of course I did.
And
Okay, found near handler. Type
35.
constructor 35.
Oh, and right.
35.
Yeah, delete the action and put a string now because that's what it returns.
Delete the action and put a
35.
string. 35.
Handle action doesn't exist anymore, right?
Oh, put a string.
It's lowercase.
That's not how you do that, yeah.
Yeah, string is the module. Okay. I know why, because go back to the okay, now the problem I think is on the other file.
This one?
Yeah, don't run. Let's see. So okay, delete this thread, garbage. This loop as well. The spawner. How are you using this? A handler on the other code? Can you show me?
Handler goes here.
We just pass an S and then you on the remove until you deleted the no, I'm looking at the up there on 35 and 40 24.
Mhm.
Okay, so you just remove the buffer altogether, right? So okay, that should be fine. Just go back then. Right. So the spawner should be that. And then if okay, you can
Don't we
delete
just
this.
do this?
Yes, now it is. No, I mean you don't even need this, right? You can just do spawn computation spawn. Yeah, because I was passing this as a thing, right? Now it's just this. So okay, right? It's accepting, and now open the Emacs
Yes, we
client.
have an Emacs client. Don't ask us why. We do. It is what it
It's
is. It is what it is.
it's surprisingly convenient to do this.
Oh, if you have an operating system in form of a text editor, yes. You can
Emacs
do
is a
whatever.
great operating system. It just needs a good text editor.
That's why people made Vim work on it.
Okay, so I don't remember. What is the shortcut that I need to do stuff?
Uh, just select from line 1 first and evolve the region. Yeah, no. Yeah, until there. Evolve the region
No, wait a moment.
and then
There.
Ctrl X, Ctrl E on the line 21.
So
No, I
evolve
mean,
the region.
yeah, you can evolve everything, but yeah, that doesn't matter.
And then which line you said?
Yeah, you already ran, man.
Accepting,
nice.
accepting, hello.
Now send one request again. Put it to side, by the way, so we can see it. Accepting. Let's see it alive.
Which line? 21?
21. Yeah.
Ctrl X, Ctrl E.
Okay, it's not exploding. That's new. That's good news.
That's good news. Yeah.
Okay, now let's go back.
But now we
You can
can
kill.
change the thing to do this deserialization.
Yeah, now we can add the black.
Yeah, now we can add the bled back. Cool. Right.
Can delete the print. I don't think you
Question.
need the
We need something in here, no?
You need to pass the buffer.
Don't remember syntax again.
Oh,
Is it
just
this?
buffer. Yeah, like this. Yeah.
Yeah, okay.
And then just remove the and then
we
you can
do
remove the print
this.
down there.
Well, if you're gonna remove the print, I'm gonna remove the.
Yeah, please. I hate this. Right, so it's gonna do
Oh,
this
that's not
garbage.
bad.
And it's just gonna write. Yep, that's it. So let's see.
Let me just. We need to change the thing.
All right, pass the
str.
buffer. Yeah.
So I'm gonna kill this.
Oh, you died.
The thread should be dead right now, right?
Yeah, well, I hope.
We hope. Okay. Structure file system has not been declared.
Oh, the payload. Oh man. If you turn on the LSP, you will see the problem. By the way, do you have LSP working? No, use this here. I have it. I will provide the code. Don't worry.
But why are we calling this? Don't we have this exact function going on in the other module?
Just a sec. Here, Lemos, don't suffer no more.
Don't suffer no more.
Just evolve this, man. Just trust me.
Scratch. I should put this in my configuration, I believe.
I need to improve this mode now. I was streaming stuff from the actual mode.
Evolve this, and now I do Ctrl X, Ctrl E.
Well, you already evolved, right? So what's the point?
Yeah.
Do you have straight or do you use a normal garbage?
What do you mean straight?
You don't use straight, right? The functional package manager for Emacs.
I use whatever is in your config back in the day.
Which I moved on ever since, because on straight you can put the GitHub repo, you see, and then it just makes your life easier. So in your case, just go back there. You already have the SML mode, so
just go back there.
You see the lines. Go to line 13.
Oh, I see. These I don't have. This.
Yeah. So go to line 13.
13.
Yeah. And then go to the end of it and evolve this. Add to list. And then evolve also line 17.
Here?
One back. Yeah, there.
Here.
Okay. Now go back to the SML thingy and do spawn LSP.
Oh, LSP first.
Yeah, LSP. You don't have the candle mode.
It seems to be.
Oh, you don't have melee probably. Oh man, okay. Dude.
But this was kind of working before, no?
No, it's because I changed the name. Go back there. I put candle mode, not SML mode, which is your mode, right?
Well, not the mode that I want, but yes.
Yeah, candle mode, SML mode. Yeah, the rest you can leave as candle. Who cares? But you need to evolve this again. Yeah, now this should work.
Do I need to do Ctrl X, Ctrl E here?
No, you don't.
I don't know if I have melee at all.
Yeah, you should have on the. You do. Okay. It's on the config. But here's the problem. The payload is on the there we have a dependency order on the files because the payload is defined later. You see?
Oh, so you mean here?
Yeah, but we can't mix both because then the communication needs to well, the bookkeeper uses the communication and the communication
Circle.
uses the bookkeeper. Yeah,
But here's my
circular.
question: can't we? Oh, wait. Wait, the bookkeeper uses communication? Oh, this is where the main function lives. Yes,
Yes.
I see.
I mean, technically, we can put everything on the same file as the attendance. Um, but let's not do that. And in this case, can you just pass it as a function as well for the
Just pass it as a function.
like?
I have
Do you
no
agree
idea.
that on the okay? Let's do even more abstractions. You see the line 120?
Do you want me to put a function here?
You make another function that picks a
A string?
thread, a socket. Sorry,
A
like
socket?
yes. Do what I'm saying. Like do a I don't know handler, whatever socket. That I mean,
No.
just put an argument. You don't
Yeah.
need parentheses. Just put like socket.
Just put socket.
Yeah, just put socket. No, I mean lowercase, right? It's a
Socket
variable. Yeah, and then just put equal,
equal.
and then you're gonna do a nested garbageness.
Man, isn't
So
this really worth it? Can't we just move this to another file?
man, it will be out inside the other modules, so I don't think it's worth it. It's better to do
Sure.
read organized. So open the on the other side, the other file. Go to the ble on the
Yeah, I'm
communication.
there.
Cut the ble.
Cut the entirety of this.
Yeah, this shouldn't be there.
Oops.
And then you put the ble in the let before this. No, before this. Yeah.
Yes.
Okay, and then you call ble.
I call ble.
Man, why is it this trailing spaces? Yeah, ble. And then
Um,
open close parentheses. The argument will be communication receive until EOT,
yes.
like the thing that is
Yeah,
below,
it
yes,
is
and then you
getting
pass socket,
complicated to read, bruh.
and then you pass socket. I mean, you can organize it better, but who
No,
cares?
no, no, no. This is this is like multiple levels of continuation passing style, bro. Because
And then you
this
pass socket to it.
you
No,
pass
I mean you
socket.
forgot this. Yeah, socket there, and then you pass handler to the spawn.
It's in here.
Ta-da! Yeah, that's it. Now go back to the communication.
Yes.
Now we need to fix the contracts because they are you don't need to call it again right anymore.
Oh,
So
Blaze here.
yeah, so you need to pass the handler. That's still true.
That's still true. And is this still the
Uh,
correct type?
yes, that's still true.
Yeah.
But you don't need to call this str blah 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 blah. You just need to call the socket close. You just call handler and then socket close.
So fundamentally,
Mm-hmm. Yeah, the closure got simpler.
I mean,
Okay.
Marinho, am I just stupid? But like, I understand what you're doing, but do you think it's worth using like, you
What
know?
if Marinho says yes?
Well, Marinho is really used to continuation passing style, so he will understand these things and how we're doing it. I just don't know if you're gonna remember, which is the problem. Maintenance. We need to remember shit.
That's not quite continuation passing
Yeah,
style though,
that's
because
just
we are actually
nesting.
returning.
No, but
Yeah.
it is because we are always passing continuations to continuations and so on and so forth. Look, this it's inside this function that is inside this one that is inside this one, and like it's literally embedded in here now, quite literally.
Yeah,
I
but we are
mean,
returning, so it's not continuation passing style.
I mean, that's not
yeah,
incorrect
I
to
know what you
say.
mean. Like, what you mean is the inception. That's what you mean.
Yeah,
Uh,
But
What is
well,
this?
again, this type of inception that we're doing, when I was doing the Racket Tower with my Marinho, we also reached a point in which I was passing functions as like, if this doesn't fail, run this function. It was more explicit CPS. In here, it's very hidden because there's many layers. Like, if you read the type signature of handler, you will never imagine this is what it's going on.
Oh, why not? Don't you have imagination? That's like a Dadaism. 130. So on the bookkeeper. Only odd.
Here.
130. So when you call it, and what does it say?
It's
To the sequence
saying
name?
type error in function application. Function communication.spawn. It should receive three things, and we are giving it three things.
Wait, it should receive the socket, the string, which is a function, and then int, and then an a. And then one of the arguments it cannot be unified. Okay. So that's the reduction of the
Yeah,
ML
yeah, but
in the
isn't that
mirror.
just saying unit here?
This should be unit, yes. But here's the gotcha. The blah. Is it returning unit?
It depends on what this is returning.
I
So what
think that
is
returns an integer.
f right? Data set file name zero content. We are not. This returns unit for sure. Where is the data? It's in here. Set. We don't have the type signature, but this is pretty sure returning unit. No.
Put the typing signature there, like unit.
Didn't change anything.
Okay.
Let's type. Let's also give the signature for Blair.
Yeah, good idea.
And it is still the same issue. Precisely the same issue.
So let's see.
Which is kind of surprising.
The handler S. What? Okay, the handler S is the composition of the blah with the. Not a composition, right? It's not composing anything. Receive until EOT. What's the argument of receive until? It's the delimiter and a socket. That's all.
Yeah, that's
And
all.
then returns a string. Can you put a string annotated? Like as a
It.
return?
Oh, sure.
Line 12. Yeah.
Didn't change anything.
Okay, let's read. On communication spawn, it's saying socket to string. Which function is that? That's the receive
Should be the
until.
handler.
That's the receive until. So it's
No.
inside the blah.
Yeah. So this
Returns a string.
returns a string given a socket.
Yeah.
Um,
And then it's complaining that it probably doesn't interface with the blah, which accepts a
no, if
string.
this returns a string, this should match with this.
Yeah, the types are correct to me. What the heck?
So it's saying reason can't unify string to open close curly braces found near.
Can you go to the communication spawn? It might be there.
It's here.
No,
Here.
I mean the other function, the function, right? Not this.
Communication spawn, not this.
Yeah,
Oh, this
the
one.
actual function. Yeah. So handler, we pass the S to the accept, and then the handler, it picks a socket and gives a string, which is what blah does. Oh no, blah returns unit, right?
Oh.
So handler does nothing. Yeah, so change the accept to a unit on the signature.
Here.
Okay. I don't think that's it still. Oh, it is. Okay.
That's progress. Let's now go back to here. And this is already evaluated, so I just can do this. Accepting. Wait.
Beautiful. Is it writing?
We have to check that.
Check the temp.
So you said temp?
Without the tilde. Temp, canteen. You didn't create?
No, didn't create.
Oh, you mistyped the path. It's TMP. Yeah. Ooh. Yeah, that's it.
Nothing.
Type hexo mode because maybe it is writing. Okay, there's
No,
nothing written.
there's nothing written.
So we are missing the info, which is, well, just a detail, right?
Minor details. But there is a way to check for that. We just go to F right in here, and because this is impure language, we can just do this uh, there, and we can just, I forgot how to print stuff.
Print,
Print
and then the thing you want to print.
file name content. Is that how
I
it
can't
does?
print the content. You need to transform it to a string
Is
before.
there a convenient way to do that?
Polyml dot make string.
Poly ml make. I don't remember if there's a
Yeah, like all lowercase.
all lowercase like this.
Uh-huh.
Cool. So this should work,
And you
right?
don't need the last semicolon. Yeah.
Like this?
Mm-hmm.
Okay. So then we're gonna try to see if this works. It does. Go back to here. Um,
So it is
TMP,
receiving.
Canteen, ABC, and whatever is written there that I cannot
Trashy.
translate because I'm not Marinho.
Marinho, does that say trashy?
Uh, ABC from list.
Probably
747.
reverted. Just have that in mind.
Yeah,
Let me
Marinho is
see.
very
Brackets.
fast on reading these things to ask for some reason.
That's
Asking.
because you can just spin up bracket and do. I think it's
You know what else you
uh,
can spin up as well to do this? Python.
what? Oh, Python
of,
sucks.
of course he would say that. Anyway.
472.
You can translate that on Emacs, by the way.
It's
No, but
one,
that doesn't really matter because my issue is that it was not
3,
receiving stuff, but it is in fact,
8,
which kind of
and
means
7, 9.
That the data set is wrong, right?
That is trashy indeed.
Okay.
okay.
Great.
So, but we discovered that the entire communication process apparently it is working. What is not working is in data.set for some random reason.
Yeah, it is even writing the file, but it doesn't.
That doesn't make
Yeah.
sense to me. So we have an entity, a position, and a to write, which is the content.
Are we
Uh,
flushing the file?
Should we flush the file?
That's a good idea.
So where is the function to do that?
I don't know.
Awesome. Uh,
So it's time to research on Pauli's awesome structures.
um,
Sounds like a child's adventure book, right? Pauli's wonderful abstractions.
Welcome to
World.
Poly, friends.
Poly World. Sounds like a theme park.
So Poly, ML. I don't have patience anymore. I'm gonna go straight up to the source.
I
Would you
mean,
take your kids
Polytoad
to
is
a
pretty
park
good.
with Polly's parrot as a logo?
So we want bin.io.output. That's what we are using.
Would you,
Uh,
Maninho? Would you take your kids to a theme
Push.
park with this as the mascot?
No.
What a specific question. You as a parent, don't you feel invited to have your your child looking at this beautiful mascot?
Hey, wouldn't you feel safe trusting Polly? The security of the park, everything is encoded using SML.
Man, I'm really surprised how easy it was to make it work, even though we are using
and
very
the dumbest
unusual.
thing,
No, it's very
and the
unusual to
dumbest
do
thing in
this,
the
man.
problem.
You keep, how can I say? This is very. There's many layers of functions go one receiving the other here,
An
and
F sharp would be done with this, but I think we're getting there. Like we're going faster than before.
yeah. So here's the problem. I search for flush in the module
I
that
can't
we are.
find it. I can't find on the module. Where did you find it?
Source code.
Oh, you did find on the source code.
Yeah. No, I didn't find. I
And
didn't find the flush though. I found the
does it
module.
inherit another module? Oh, it does, including imperative IO.
Okay, so imperative IO should go there. Here. Do we have flush here?
And just
Please.
search on the entire. Yeah, flush out.
Flush
go.
out. Cool. So how do you use this? You pass it out and it does some
By the
stuff.
way, do we close also the file? I don't think we do.
No, we don't.
Probably a good idea as well.
Probably a good idea. So we need to do flush it first, right?
Oh well, you write first and then you flush, right?
Wait, maybe I'm confused on the semantics of flush. What is flush on the semantics here?
Flush is like, yeah, I want you to sync and make sure, tell me that you wrote or not to the disk at this moment.
So we're gonna do outstream.
And clean the buffer, basically. That's like flush.
And then we want to close out.
Fruit Loops mascot. Man, Fruit Loops, that's true. That's Polly. Man. Fruit Loops. It's like the
typo.
Brazilian version of Polly, right? It's just a Tucano.
Cool. Let's see if it worked. Control X, Control E. Control this. TMP. Yes. Revert,
Imagine it's
yes.
like Disney.
Haha!
Oh, yeah, so that was a problem. Okay.
Let's also fix the get, by the way.
But you closed. Okay.
So should we also flush?
Just close, don't flush.
Just close, don't flush.
I mean, you can, but there's no need to flush.
It's so it's so weird to me. We are flushing the buffer after writing it. Shouldn't we flush first? Are you sure?
No, yeah, absolutely. The flush is like the sync, right? It's not the remove everything.
Ah. So here's the big deal. We don't have a flush in. Well, we don't want to flush actually. We want to close.
Poly is a implementation of the standard ML. Fernando. Yeah.
Oh, there is a close in. Thank you. In stream. And we need there.
Like standard ML has many implementations, right? So you can have ML Tone, SML New Jersey, SML Sharp, and then
yeah, we should actually
PolyML
give Fernando a little bit more context. So SML, Fernando, is a very it uses a traditional in the sense of modern approach of developing a language in which you make the specification of the language and then people are free to make the implementation of that specification, you know? So you have one standard, but you have different implementations, so different compilers. Imagine that as if C had many specs, has only one spec, sorry, and many compilers.
It's esoteric today, but back then, like the 90s, like it was actually more enterprise friendly than OCaml, and F Sharp wasn't even a thing. So basically, you gotta think of this as well. Like the language just faded in obscurity today. Yeah. It's just like a language that's used by nerds at university. Like just there's literally one professor that uses it that I know of, which is Harper.
In the C example you were talking about, C has multiple compilers, right?
But it doesn't have a single spec because that would be madness at this point.
Well, there is.
Actually, C does have a single spec.
It's NCC.
Oh, that's true. NCC. Yeah, I forgot about
that. Comolisp is a standard. Well, I think even Haskell is a standard, right?
No, Haskell it is. Standard, yeah. Haskell also has a standard, but I got confused. I meant to say C++ spec.
Well, Rust doesn't have a standard.
C++ does have a spec, by the way.
Sure, really?
Yeah, it does as well. What else has a standard? Scheme has a standard.
ECMA.
Oh,
I don't know that one.
ECMAScript is how they call JavaScript because trademark reasons, essentially.
But it has a schema, right?
Oh, Oh,
Yeah, it
isn't
does.
ECMA the thing that you do to use C to do browser stuff or whatever?
No,
I
no.
think this is CGI,
Uh,
right?
isn't ECMA script ECMA whatever script?
É que whatever.
Uh, there was a C thing that uses this, and
Standard scripting languages,
I don't
blah blah.
remember
You know,
what.
including JavaScript, JS script, and ActionScript.
Yeah,
So
but there
it's a
This is
is.
the spec,
also
right?
um,
I don't know. I just remember
oh, I see. So
because
it is standardized by ECMA International. That's why the.
yeah, but there
Ah,
is
okay, again, this is
something with this in C. I remember. Anyway, so what are we missing now? We managed to make the devil works. We should actually rename this thing though. So I'm gonna call it receiver.
Uh, well, that's not really receiving. I mean, it is, but that's a generic name. Like what it's
It's
actually
miles
doing is,
better than ble, in my opinion.
well, yes, but that doesn't make it any better to just rename for another slightly better, right? We should aim for higher. So
Yeah,
let's
yeah.
see.
Better names are
Uh,
better.
name it as action, because that's what it's doing, right? Act. I don't know. Action. But by the way, about the SML being business friendly, there's this book, by the way, Fernando, if you want to take a look at. Uh, it's Unix SML, Unix SML programming, something like this. That the guy basically does SML programs using SML. Well, does Unix programs using SML. Sorry. Uh, and you can see that like in 90 something, it had awesome tooling already. So it's just that today it's like rusty and forgotten, basically, which is very sad.
No, it's not Rusty because it's not implemented in Rust.
Ah,
You can't say that word
ah,
anymore.
ah. I knew it that Marinho would say that. Let's continue here, people. So what's the next step? We've managed to fix the demon. What is the next thing?
Uh, so we are writing. So now we can start doing the looks to the table and doing all the garbage there.
Mm.
Like look at the table, write to the disk and this position,
Are we
save
gonna
this
follow
hash.
Marinho's step by step, or are we gonna try to do
Yeah, but
the?
step by step, yeah.
Are we gonna do the reading first or the writing first?
Let's do the reading first. I think
Let's
it's
do the
easier.
reading first. I agree on that. So let me pick the list.
Actually, if we don't have anything to read, what are we gonna read?
We have trashy to read.
But we don't have
Mhm.
bytes.
What do you
Well,
mean?
we do have a file, but we don't have the hashes and all the garbage for the file.
Well, we're gonna have to make this right now, no?
Yes, but here's the problem. Like, we should persist as well. Do you agree we should persist the tables with the hashes and all this garbage?
We should persist the tables.
The tree and all the stuff, right?
We
So,
should. Otherwise, recomputing that when we start the server is gonna
Man,
suck.
but isn't
yeah,
that gonna suck also because we're gonna have to, like, we literally did the most laziness approach to deserialization imaginable. What are we gonna do to do more complicated structures like trees and stuff like that?
to be fair, I kind of like this deserialization approach. I don't have a problem with it.
Really?
Yeah, it's just plain simple, man. Like, it
No,
works. It's simple.
no, it is plain simple, but well, how can I say it?
It's
Uh,
not general.
yeah, it seems like a temporary solution, a temporary solution.
I can't see anything else we need there.
No, in this particular case, yes, but let's suppose right now we're gonna make what we're gonna make. We're gonna make a function called serialize because we want to serialize stuff. So we're gonna make a function here called serialize. Uh, what are we gonna receive, for instance? And this will return unit, of course.
Wait, serialize on the right.
Yeah, we're gonna ask the write module, write this table for me.
That's the response you're thinking then.
No, I'm not thinking about the oh, this is in the correct wrong place. Sorry, this is in the payload. I forgot about that. So somewhere in a module, we're gonna have to have a function that serializes stuff. I don't
Which
know where
stuff,
that should be.
man?
We have
I
two
don't
things that you
follow.
mentioned: Merkle trees,
Hmm. Oh,
and
you mean the
tables.
hash table?
Yes.
Okay, yeah.
Where should that be?
On the bookkeeper, I think.
Bookkeeper. Okay. So we're gonna have a function.
By the way, I was thinking, I think we kind of need a write ahead log of some sort, right?
Mm, write ahead log for what exactly?
Because to be sure that you changed, I mean, that's further, but if we want to do recovery and be sure that we wrote something to the disk and not like start writing and then you fail, right? Imagine that.
Mm-hmm.
Uh, we should write first to the commit log, you see, and then
Mm-hmm.
once it's like transacted there, then we can actually perform the changes on the files.
Yeah, I agree on that.
And it's not that hard, by the way, to do a wall. It's kind of easy, but the problem is doing it with distribution, which is
Yeah.
funny to say the least.
Yeah, but we're gonna do that a little bit later. Let's first think about the serialization for today.
Or maybe we will not do that.
Um, so here's the thing. Uh, we want to serialize two types of things, right? The Merkle tree and the hash the hash tables, right?
Uh, Wait, say it again.
We want to serialize to the disk two types
Mhm.
of things: hash tables and Merkle trees.
Yeah, I don't. I mean, we can recompute the Merkle trees, but if we can save, it's easier.
I see.
Actually, recomputing the Merkle trees strikes me as a very bad idea.
I also think so because we're gonna have to. That can be expensive as fuck, no? Every time.
Well, you would recompute as you need, right? In my
No, but
idea,
if the
It,
system goes down and you launch it again, you're gonna recompute it because you didn't save it.
you only recompute if you are going to use it. You don't try to recompute everything.
Wait,
But if you can write, there's no point on not doing
exactly,
it.
exactly. But we can do. I'm just asking this because are we gonna do two functions for each case, or do we have a way to make a single function for both?
And just loop over the hash table, writing stuff with a separator, and then just read it back. That's it.
Cool.
That's the hash table. And then the Merkle tree, you do the same, but you would change the encoding.
You do the same, but you change the encoding.
Yeah, you pass like write to disk, whatever, and then it does exactly what I said. Like writes the same way.
That's very
And
interesting.
then
So you're suggesting like data and an encoder.
yeah, and then the encoder does whatever, right? Converts to bytes you need, and then you just write.
And then you use a separator, like a new line.
Yeah. It could be new line, it could be
Uh,
whatever. You just need
that's
to reinterpret the data in a different way, right?
yeah. But here's the lesson learned, right? Because these things are all about learning lessons. So here's the lesson learned: we should not use delimiters for this. And Marinho knows, and I know very well why we shouldn't. Because let's suppose that in the middle of the payload there is the delimiter character. How are we gonna do that? How are we gonna read that back? You know?
yeah, that's
Say it again.
I can say it again. So the problem with delimiters for serialization is
Hmm.
that there is a chance that in the middle of the payload that you are writing, there is in the middle
Which
of
is
that.
just gonna be hashes and
Yes, it's going to
file
be just
names.
hashes, yes. But let's imagine that by coincidence, the byte in one byte in the middle of the hash is the new line character in ASCII. Okay?
Well, it's a SHA, so it has a limit of what the things can be.
It has what?
Well, it limits what the values can be on SHA.
Exactly, exactly. But in the case of a hashing function, how are you going to predict which values will not be ever in there?
What's the problem on a hashing function?
The problem is that let's suppose because the new line, as far as I can tell, is 10, right, Mani?
yeah, numerically it's the number 10.
Yeah. I can see this byte being written as the output of a hashing function, for instance. and then we are fucked because now we cannot
It-
determine
Wait,
this
I
new
don't
line.
follow, man. This function is picking the hash as a list of garbage without the new line, without anything, and it will have a fixed length, whatever. It's a hash.
Oh, that is the solution. We're gonna write the length on the
Yeah, and
file.
like we're gonna use something like SHA. I don't know. It's a fixed length value.
Okay, then we're gonna write the length, right? Or you're gonna also always assume when reading that the length is always the same?
The only thing that's not gonna be the same is the text that comes the preamble, right? Uh, the text that comes before it, like a file name, let's say. Like you would
Yes.
have, for example, file name and then hash. You know the hash has this size, so if you start
Yes.
reading from the
Yes.
end of this of uh,
Yes.
the row, right?
Yeah,
The
so
line.
just for you to have more context, Magetta, how did we discover this? We were making a table in Racket Tower, and then in one of the columns of a number, I added the number 10
Mm-hmm.
there. And we were using delimiters at that time. And
It
the
was
delimiter,
new line.
yes. And it took me, and well, took us, I think Marinho was already there, it took us hours to discover that. That,
First.
wait, this 10 here is the cause of the deserializing breaking us, like going to hell. And then that was when we decided to never have a delimiter character. And we always put the length before the data. That's when that decision happened. That was when that decision happened. So the data is going to be a list, right? You said?
It can be like word vector. I think you pick binary already. Oh no, actually, sorry. The data is the yeah. I think we need to convert it to a. It could be the hash table, or and then you do the conversion there,
Yeah.
or it could be a generic thing that you pass the encoder. The encoder gives you binary, and then you just write the binary there.
Yeah, no, but I was thinking about this being a list of some sort, and then we would map this list
Okay,
with the encoder.
here's okay. I have two options. What the first one I was thinking of this was this. You pick some random data. This is
Mm-hmm.
just like a dummy function, right? It's just gonna write to the disk. You pick a random data, which it can be a hash table, can be a Merkle tree, whatever. You give it to the encoder. The encoder gives you bytes. You write the bytes to the disk using the data set. Right, and that's it.
That
Uh,
works. That
so
definitely
that's
works.
yeah, that's the dummy part. But you need to still convert on the encoder, do all the boilerplate. The other option, which I think it might be more interesting, is you write to the disk. So you're kind of in the serialize, it would become the encoder. So you write everything the same way to the disk. For example, a hash table, you write it file name, you write some metadata, whatever it is. Uh, and then on the continuation of the same line, you write the hash or hash first and then metadata. And then next new line, it's the new entry of the structure. You see? And then on the encoder, you actually just gonna read all of this shit back, and then you give to it and say, yeah, it's our job now to pick this list of these things that I parsed, and then you reconstruct that structure that you want. So if it's a hash table, it's gonna interpret the lines as entries of the hash table. If it's the Merkle tree, it's just gonna pick the hash and insert the hash there. You see?
Mm, I don't know if I quite followed from the beginning of it though, because at the beginning you said that instead of doing this dummy thing here.
Like, and what I'm proposing is an inversion. What you're gonna do there is basically encode them in different ways, and you're gonna write binary. That's fine, right? That's the
Mm-hmm.
approach. What I'm saying is you encode them both in the same way, you read them in the same way back, and then you just send to the specialized encoder, so you would have two different encoders the same way as you would have now. You have two different
Oh,
encoders
I
that
see.
convert it back the structure.
I
So
see. I see. I
they are,
see.
you see,
But I don't see how we can make the same
decoder,
encoder
sorry.
working for both, though. That's my question. Because we need an
Well, you
encoder that
still
picks a
have
hash
two.
table.
You still have two. Yeah.
Oh, you still have two.
Yeah. But
Okay.
what my proposal, the second proposal is just interesting from the standpoint of removing a lot of the burden from reading back from the disk and trying to uh, like trying to change the format and doing the read the bytes differently. If you're just reading them the same way and you compose like a list, let's say, you just reinterpret the list. I think that's easier.
That is the answer to my question. So the way that we would unify them is because all of them can be built via a list.
Yeah, both receive a list and produce a hash table or a Merkle tree. You see?
Yeah. So, but then I have a second question. I don't know about the Merkle tree, but a hash table should be a list of pairs, no?
Yeah, but that's what I'm thinking. Like you're gonna have to have some common uh shared structure for both, right? So for example,
And that's why I don't know if we have. Do we have
yeah,
that?
that would be more painful actually. Nah, man, never mind. So just do one encoder per each thing,
Yeah.
because
Okay.
if like
But that
uh
idea was not bad. Marinho, did you get
even
the
the
idea?
hash even the hash tables, they will be different, right? Because one will store just the name and the other will store the location, which is like file name,
Yes.
uh
Yes. 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 Yes.
the like whatever the pointer, right?
Yeah. 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 But I understood your idea, which was what I wanted because um, that's the reason why I suggested to the encoder to be an argument because then we can make it generic.
Uh-huh.
Anyway, so we
I'll be
gotta.
right back again.
So the suggestion is to pass the data to the encoder. Pass the data to the encoder. It would be kind of nice if, given the type of the data, the encoder could be discovered by this function. But I don't know how to do that in SML. Do you have any idea, Mani?
You can take a module as an argument, I think.
That is true, but we don't have those things in the modules, though. You see?
Is there any reason they can't be put in a module?
Um, I don't think there's a reason to not put them in a module. Is that is the only thing is that does it make sense to put in a module just to have a generic function for encoding? Because now that I think about it, I think this is going to have to be upgraded to a functor of some sort, no? Because we're going to be receiving modules as the argument. Am I wrong?
Mm,
As far as
I
I can,
guess.
as far as I can tell, it would be something like this. So serializer, then you receive something that has an encoder as in the signature, and then you have a serialize function that assumes by construction that whatever is coming has an encoding function provided.
Mm,
And if that happens, we are good to go. But then we would have to upgrade the serialization to a functor, I think. I hope I'm understanding things correctly. Do you follow?
um, yeah, I'm trying to think if what I suggested is actually feasible. Like, how much work would that be? Mm, hmm, I don't know actually.
Cool. Very cool. Uh, so here's the thing. We also need the entity here. Because what Marinho said, what Magetta said, is to just call the data. And we're gonna use the set.
Like, what you want is basically a type class, right?
Yes! But that's, as far as I can tell, to make a type class with
Here.
constraints, you basically demystifying type classes. But I want this in ML, which I think the functor does the trick for me. Let's see what this is about.
Or it uses a camel, but it doesn't actually, well,
Yeah, but this is parametric polymorphism. It's fine. Oh, I see what he did. You see what he did? He transformed a class into a type.
Yes, look at the comparison of the inferred types at the
Uh,
bottom of the page. Near the bottom of your screen, right?
yeah, I know. Yeah, but this is still not enough for our case because we don't want this. What we want is,
I'm
gi-
black. I hate Benevides.
you loved him. We all know it. We all know
He's
it.
psyoping me, man. Okay,
So
what are you guys
here's
doing?
okay. So I was talking to Marinho, and I kind of wanted the serialize function to know its encoding based on the type of the data.
You need a functor then.
Exactly. And then
Oh,
Marinho sent
actually,
me
wait,
this.
wait. To know its encoder.
Yeah, I don't want it to pass the encoder. If it's a hash table, it will know how the encoder is supposed to be. If it's a Merkle tree, it should know how its encoder is supposed to be.
Yeah, you
That is
need
a
a
type
functor.
class in Haskell. But I think in ML, you do that with functors because
Mm-hmm.
you put the thing as in a module and then you say this module fulfills the constraint of having an encoder function.
Yeah.
And then that's the magic. But then Marinho sent me this, and that's what we are taking a look at before continuing. And the thing that this guy is doing is show me how you can do some stuff that the type classes do in Haskell in OCaml. And the trick that he's using is instead of having a class with the things like, oh, if you have a type class show, you're gonna have the show function. You can just put that in a record like this, and then the type signature difference is going to be, in Haskell it would be, given a value of type A that implements type class show, it returns unit. In ML would be given a parametric type value of type A show, and the value, you're going to return unit. But that's
Man,
not what we
wait.
want.
I remember a file. Do you remember? Let me find a file here to shame Okamo. Just give me a sec. Heresy, heresy.ml, I think. But go on. I need to find here doing heresies in Okamo.
I want an example in which he's using a type class example that has another constraint on the back. That's what I want.
Here we go.
Oh, this one. This one should be it. Oh, I see.
Check this code out here.
Okay, so that's how he does it. He needs to do this hacking to have the equal and the num constraints. I see. Checking the code. So we have a type, whatever that is, and then we have wrappers,
Mm-hmm.
and then we have a let x wrap1, and then you are creating a funct, and the a there.
So you basically have a record that has
Yes,
a implementation, a generic type A, and
yes,
then it has as an argument this guy that is ABC that takes an A to an A. So it can be an
yes,
identity thing,
yes.
right?
Also yes.
And then you can have a wrapper that takes wrapper one and two that have a function, right?
Yes.
And this function is implementing. So sorry, it's the same thing as the record up there, right? So which is the function in this case. So it's just
Yes.
wrapping inception after inception.
I see, I
And then you
see.
declare a value saying wrap one, and then you implement it with ABC equals XX. So it's
Identity.
identity, right?
Yeah.
And then Okamo blows up because it doesn't know where A is the bond definition. So it will launch a type inconsistency there.
Really?
Yeah.
That's unexpected. Okay. This
So
post here, Marinho,
doing
I'm definitely
generics
gonna read it,
inside the field side
but I
is
don't think
dangerous.
I don't think
It's
this is the way.
Kislev. It's,
I don't think
I
this is
mean,
the way.
you can never go wrong if you read Kislev, but you know, it may not be what we want. It's just
Yeah.
something that came to mind while you
Yeah,
were
but I
pondering this
decided
problem.
two minutes before Margeta came back, I decided that I'm not gonna do this. We're gonna pass the encoder as like Ooga Booga cavemans. And then we're gonna do data set, and I believe I have the signature. Yes, I have it here. So then we pass entity 0, serialized data. And that should be it. Oops. That should be the serialize function. That should be the serialize function. And I forgot val.
Mm-hmm.
Cool. And then we are also supposed to have a deserialization function. So fun deserialize entity from where? Uh, from where? Well, what is the position? No, this is the entire thing, the entire hash table. So the position is always going to be starting at 0. So this is actually a file path, now that I think
Oh
about it.
man, I love persimmons. They're delicious.
What?
Persimmons, they're my favorite fruit.
I don't know if I know the translation of that.
Kaki, like persimmon.
Oh, the one that my dad hates it. I know. Okay, that's cool.
Sorry, but I cannot be friends with your dad then.
Uh, I don't think you can, but not because of that. um, what else do we need for deserialization, folks?
Uh,
Decoder. Right.
I think you should do. Yeah, I think you should wrap this garbage in a module and give names to what deserialization need refers to, right? But these are just generic things, so it's fine. But I'm talking about the other thing.
Yeah, the problem
Uh,
is that these things are generic. It's supposed to work on Merkle trees and hash
no,
tables.
yeah, but you need to specialize later, right? To do
We're
the
gonna have to
encoders.
specialize, yes. We're gonna have to specialize this later. As you already said, Magetta, this should I think this should be in a functor. I think
Yeah, but yeah, whatever. Let's type incorrectly, and then later we can
this.
submit our
So
paper to
data
this a peer-reviewed paper.
get. So oh, we have to also provide the size, folks. How are we gonna know that beforehand? Is there a function to know the size of a file?
Wait, why?
I don't know. That's the API that we made.
Just read everything.
That's the problem. How? If you don't know this.
Oh, go reading pieces by pieces until the end of a file.
Uh, I'm gonna assume that there is a way in Poly to know the size of a thing.
You're gonna regret doing this.
Maybe. So what? I just want a function that gives me the size. That should not be that complicated.
Mm, look at the OS module.
That's not a bad bet. OS. Like every time I'm doing shit like this, every time, I remember Zozing and Marinho saying, source code, the best documentation, because it can't get outdated. Every time.
Well,
I mean,
if you
it's
guys
true.
start complaining, just remember you brought this upon yourselves.
File size, thank you.
I warned you. I warned you. You can say I didn't.
Yeah, I can't deny that. You definitely told us. Go on, Marinho.
I mean, it's true. The source code cannot be outdated unless the code that you're running, that you compiled, is not really the same version that got compiled, but that's what source version control is for, I guess.
Is that it?
But what if they don't version control the language and it's proprietary software?
I would say
Then you're
that's not.
screwed.
Yeah, but that's really unreasonable. Nowadays, everything is version controlled. That's not my problem.
No,
The
it can
problem.
be, but what if it's closed source?
Oh,
What do you
but
do?
then you're screwed.
Like AFL. I mean, you might have docs for AFL actually in an IDE. So okay, so we have the file.
Okay, but I think we're done. These are the two dummy functions: serialize and deserialize. Now, what I think we should focus on is to make the encoder for hash tables. Um, so hash table encoder. And then here comes the first problem. I don't remember how to make the type of this thing. So
Well, thankfully you have it there, right?
is it hash array hash or something like that?
Yeah, that works.
Here's another issue. Oh man, I really want to type classes now, but okay. This also changes, right? These are the individual elements, right?
Yeah,
We also need encoding for those.
yeah.
Uh, cool. So before doing that, let's make a hash.
Man, why don't you do just the dummy approach and do a hash file encoder, and then you do that first, and then you
Sure.
do the locations. Then
So
let's do
then,
it by pieces, like step by step.
we're gonna do hashable
Yeah.
hash, and the return of this should
Parentheses,
be parentheses, yes, and the return of
input
this
a
should be a
input a
vector.
value. You're not picking any value.
I'm not picking any value. Oh, this is
The
like
type.
table.
Yeah.
I don't remember how to do the vectors, whatever nonsense.
Word 8 vector dot vector.
Okay. Word 8. Which, by the way, I don't have LSP working anymore for some reason.
It's you just enable the bomb buffer. Just enable this. It's it's word 8 vector altogether, and then dot vector. And why is it breaking up there?
I have no idea.
Can you save?
Yes. Oh.
Yeah, that's the problem. So vector.
And is it
Yeah, it
vec
doesn't
or vector?
complete this sort of. Yeah, it's like this, but it doesn't complete this garbage. So equal, and then you can do your stuff.
So the first thing that I think we want is to see what hash array provides us, I think. So is there a map for each? That's kind of the thing. So hash array. Um, there is a fold, but oh boy. Do you have any recommendations for this, Magetta?
Sorry, I was eating that.
That's fine.
Convert it to a list.
No,
We don't
want to
and the
convert it to.
values.
Wait. Convert it to a list.
You just need to iterate, right? You iterate and then you convert everything to. You convert everything. Depends, right? If we have this can be very large, so we're gonna send everything to memory at once. That's a bad idea. We should write in pieces, right?
I'm gonna say you are right, but I'm gonna pull the same argument that you just used, which is let's do it the dumb way first.
Okay, so convert everything to a list of tuples of key and value, which in our case, go back there. What is the hashable hash again? That's a type.
This is the value, and this is the key.
Which we are implementing as word, so it's already bytes. So how convenient. So it's already bytes.
Yeah, no, but this is an implementation detail. You should not take that into account.
Okay, so
we're
gonna need an encoder on this hashable as well, but we can do that later. Actually, put it now, like val encoder. Like, yeah. Actually, it's a function, right? Fun hash encoder.
This is identity.
Hash encoder.
Hash. Oh, hash encoder.
No, I mean, yeah. And yeah, put identity for now.
Yeah, but this is not a function. We need to receive stuff.
Oh, ID. Just pick A and pass A. I don't think ID is a function. I'm not sure.
Oh, A and returns A. Cool. Then we're gonna just do it like that. Hash encoder. And this is a hash. Oh, this is not a hash.
To word 8.
No, this is a hash to word 8. Yes. So word 8. Like this.
Put actually word8 vector dot vector. Oh man, you have the company and the Corfu at the
Yeah,
same
I
time.
have both. Ah, okay. Here's the issue though. What is it? Where is it? Oh, here. Um, this allow us to know how to serialize this now, right?
Mm-hmm.
But we still need to do the folding, right?
Mm-hmm.
You said that you should transform this to a list of pairs. Is there a way in the list module to do that? Because in the hash array, I don't see a way to do it.
I don't think there is anything on the list to do it. So let's see on the let's see hash array.
Oh,
Oh, there's fold. Look there.
you can do a fold, yes.
Yeah, but what is this? Does anybody know?
Key.
It's because the keys have to be strings, right?
Yeah. The
The
key
key
value,
needs
and
to
then what
be.
the B is probably the B is the accumulator, and then it returns B. You see?
Okay, so this is perfect then. Let's do it. So this is gonna be fold aux of some sort, and in. Here we're gonna do hash array fold
Why didn't
fold
you call
aux.
it fold meow or fold nyan?
This is converting something to word vector dot vector empty. How can I make an empty vector of that type?
Wait for what?
I need to create an empty vector of this type.
Mm-hmm.
What?
Uh, I was thinking of actually putting everything on a list and smash it together, but I think there is a word8 vector type dot. There's probably a tabulate.
There's not nothing.
Wait a sec.
Actually, I can check it here.
Because it
Word
has an
8.
array, you see, this garbage is just a vector, so it should have, in theory.
Actually, there's no word 8 vector in here. Maybe it's an alias.
It could be word8 array. Check that. Probably shares the same function API.
Oh yeah, it is in here.
Mm-hmm.
So how do I create an empty one?
So you do have a concat, and then you pick a vector list. You see? Um,
Tabulate is here also, by the way.
oh, there from list. So use that, man.
Oh fuck. Okay.
You just convert things to word8, and then you just mash them together.
Oh, you want to do it with a list then?
Mm-hmm.
I don't remember syntax for lists in SML. Again,
It's well,
list.
it's open close.
Open
The
close. So this is gonna be this. And what is the last thing? What is it? Hash 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 here. Initial accumulator, then the value, then the thing. Cool. So this is stable.
oh, you can actually pass new instead. I think that's better.
New here.
Yeah, list new. Yeah.
Okay. Let's define this guy now. So this guy needs to receive a key. He needs to receive. This is the name of the key you guys said, right?
Mm-hmm.
This is the value, correct?
Yeah, the element, the
And this is
value.
the accumulator.
Mm-hmm.
So can I pattern match on tuples like this?
Mm-hmm.
And there's actually a triplet, so this is the ACC. And you should return something of the same type as ACC. So the key is hash encoder. So we should do hashable hash encoder key. Actually, this is the value. In fact, this is the value because this we know it's a string. So it's gonna be something like hash, no, not hash, encode the string which is the key, then concat this, and then ACC on it. So how do
Well,
I
you
serialize encode the string?
byte dot
Byte
from string.
from string like this.
I don't know. I think it's capital S. But check if this function exists. I think it was either there or on the other garbage.
Byte. String to
Bytes, string
bytes.
to bytes. Yeah.
String to bytes. This plus plus is probably also wrong.
Mm.
Uh,
But notice that this converts this garbage to word8 vector. Okay.
word 8 vector, which is what we want.
Yes, but we want to mash them together in a list, right?
Oh, that is true, right? ACC is a list.
Mm-hmm.
We're gonna have a list of word 8 vectors.
Yeah,
Okay,
exactly.
okay. But that's kind of like flat map later, no?
Yeah, I hope.
I hope.
Yeah, I
I
mean, I
hope.
just don't know. Probably there's a concat. See if there's a concat on the word8 vector.
Sure.
If there is, we're safe.
Um, yes, there's a
There is.
concat.
Oh, thank you. Unsafe. Non-call, unsafe cast. Look at that.
uh, unsafe cast. Awesome. But I want to know how to concat lists though. What is the thing here?
It's the operator is you can literally type list.concat or use that operator, the at sign.
At this.
Yeah.
Okay. This is also correct, and then this.
Mm-hmm.
Cool. You
But,
said
but wait,
what? And this is not correct because there's no error in here. It's an equal.
the okay, they are all correct indeed. Yeah, that's fine.
Okay.
But wait. That's not gonna concat, right? What you want is to append, not concat, because these things are not lists.
Oh, that's true.
Yeah, you can make the lists, just put them between parentheses,
Isn't that like
between
the most inefficient thing
word
ever?
brackets. Do we care at this point? I don't think we do.
Sometimes I think you do, sometimes I think you don't. And this is wrong. There. And then here, what in the balls? I didn't want to do that. I guess we're using parentheses then. So hash array.
Mm-hmm.
Question, is that it? Are we missing something?
I mean, it's gonna write everything in the same line. Just be aware of that.
It will write everything in the
I mean,
same
it's a
line.
byte file, right? So it's gonna write everything in a sequence. So just need to know
Actually,
where. I mean,
that's a very good call. We need to do some sort of separation between them because we're not writing the lengths of neither of none of these things.
yeah.
So we're not
So
gonna know where one stops and the other one begins. So
unless
ideally,
you unless you limit the size of the key and the hash.
bro. But then you're gonna have to pad it, you know?
Yeah, which is
Oh
an
man.
option. I know how to pad. I did this on. You can tabulate and then append. Like
You accuse us of wanting to suffer, and then you say, I did the same.
yeah.
Marinho, what do you think is the least worst?
Be right back.
What is the least worst? What's the least worst? Uh, I don't know. Think, I mean, eventually we're going to do length prefixing anyways, right?
We should be careful with this eventually in the future, because if you say that too many times, we're not gonna do any of them.
No, what I'm trying to say is if we're going to do that eventually anyways, why don't we just do it now?
The length, you mean?
Yeah.
Okay. And so we're gonna have to do a little bit more things. A little bit more things. So let string length, I'm gonna assume that there is a length for this nonsense. And I need to remember that there's a vol in there. There's a vol in there. So do we have length, friend? Do we have length? Please tell me it does. I'm gonna be so fucking sad if it doesn't.
What?
Well, how do I get the length of a... Yeah, this size. Thank you. Marinho said that we should do it properly. Uh, and I agree with him.
Good luck then.
How encouraging. How encouraging.
How
Um,
are you going to encode the number, the length number though?
What do you
uh,
call doing properly in this case? Just
we're not
asking.
gonna use delimiter or padding. We're gonna write the lengths.
Oh boy.
So here's the question. How are we gonna know the size of the value?
We can do
Mm,
a variant, I guess.
Do what?
Basically, you say, okay, a byte has 8 bits, right?
Yeah, that's what I learned.
What we do instead is we do 7 bits for the actual number, but then we use 1 bit to tell us if this is the end of the number or not.
Wait. So you need to, if it's a correct, if it's a specific bit, the next byte will still part of the number.
Yes.
Dude.
one
Um,
thing, by the way,
That's what
on
protobufs do.
I
on
know.
the hash encoder, make it return a tuple with the size.
Hash encoder. Oh, okay. Let's just put the responsibility on somebody else's. I like that. So this is so this is 4, right? Or am I mistaken?
Uh, this is just a word. Yeah.
Okay. In that case, we're gonna do vol encoded value, encoded size.
Oh man, you've got to be kidding me.
What?
Uber announced they are migrating from. Oh man, what the heck? They are migrating from DynamoDB to Ledger Store.
Well, I don't even know what that is.
It's basically like, do you know Dynamo?
Yes.
So it's like oh man, I have a picture that describes the database in a nutshell. I'm trying to find. I'm trying to
Okay.
find it here. Yeah.
Okay. So then we're gonna do value, not value, val, and then it's gonna be key encoded key, and this is gonna be a concatenation between the string length and, well, we need to put this in this, and we also need to do this. These spacings, I don't understand why they did it that way, but okay. Um,
What you don't get? Why?
like the white spacing trailing that goes on for some reason, I don't understand.
I think this is the LSP or the SML mode. Something. One of both.
Uh, okay, then we're gonna have to do vol, and
I
this
know what it
is
is. When you do enter a new line and you don't type the semicolon, right? That it expects to go this mode. Expects, but
mhm,
the language doesn't, right? Um,
mhm.
it understands that you're bringing the white space forward. So it basically adds to the next line.
I
So
see.
yeah, it's the mode.
Encoded. This is not gonna work because we need to transform this to a thing. Magenta, how do I transform an integer to a bytes?
Word 8 dot from integer. From int, I think.
From
No, from
int.
int.
Cool. Ah, okay. That.
Question, is the engineness of that conversion defined?
That's a question for
You
Magenta.
can. I think you can know the Indianness. and check, right?
Encoded
But I don't
key.
remember.
And this is in fact concat now because I only have lists. Encoded full value. So this is append, the at, right, Mageta?
This is concat.
So, oh,
If
this is
everything is a
concat.
list of the same type, it will work.
So it's done. That's it. That's it, right? Am I missing something?
String length is integer, right?
That's fine.
You need to encode
Because
it too.
that's not fine actually. I need to do byte from word8 from int. 8 from int. Like this. Now it's correct. And in fact, I prefer it like this.
I'm oddly suspicious about the sizing of the word 8, but let's see.
Cool.
Oh, actually, by the way, this is not going to work because you need to convert it to word 8 vector, right?
I am. Is this not
No. I
converting?
mean, you're concatenating the encoded value with a word 8 from int. You see, it's a word 8. So the way I think you can do is okay, you're not gonna like this, but put parentheses in between the line 123.
Parentheses
Put
between.
parentheses in between the first argument. Yeah, this guy. And then do word 8 vector dot from list.
Yeah.
And then close and then open parentheses again.
Oh,
No, like before that.
before. You mean here?
Yeah, close twice there. And then before the word 8 vector from int. No, before the list, like word
Before the
8 from
list.
int. Remove these parentheses.
These ones?
No, the parentheses, not
These
the
ones?
square brackets. Yeah, and then go before the word 8 vector and another function call. No, not another function call. Sorry, change the outer parentheses by a list again.
Change the outer parentheses by a list. I don't know if I understand what you mean, brother.
The type you want to concat is a word 8 vector list, right? Word 8 vector inside of a list, correct?
Yes.
The type you're converting the encoded size to is a word 8. So how do you convert a word 8 to a word 8 vector? Word 8 vector from list. And then you need to put it in a list again because of our shitty
Oh,
accumulator.
fuck me. I see. Yeah, it's truly terrible. I'm impressed. Okay. Word 8.
No, just put a list. Just a list.
Put brackets, you mean?
Yeah, squared brackets. Done.
Truly terrible. Jeez.
Could be worse.
Of course it could.
I'm starting to think that list would have fewer parentheses at this point.
Ironically, right?
The nesting probably could be better.
And I forgot.
I'll give you that. I forgot the end as well.
Cool. Let's see if it compiles. Are you guys ready?
It doesn't.
It probably doesn't. But well, we are accustomed to that already.
Man, I had one professor at uni
138.
that the guy used to type on Nano on the projector
138? What?
for 2 hours, and then he would just compile the code
Oh.
in C, and it would just work. Like, just
Man,
imagine me
I love
doing.
it, Nano.
Whoo!
Sorry, what?
I love it, Nano.
Oh man, Nano is. I
Uh,
find it funny because I refuse to use Vim, so I use Nano instead, and just to
Bookkeeper
keep spinning.
39.
Man, what the heck did you blow?
39.
Huh?
What?
Wait. 39. Structure does not have a signature. Go up there.
Here?
Did you change anything on the get and set?
No. Oh well, yes. In the body of the set and in the get, I add closing, and this has a flush. I don't think that's the
Oh
problem
man,
though.
oh Lemos, you changed the signature of the get. That's why.
I changed the signature of the get.
Yeah.
How?
Closing returns unit. You need to
Yeah,
return the
it was always
input.
unit.
No, the get.
Oh, the get. Oh, this needs to be
No,
unit now.
no. No, no. You
No,
need
no.
to give back the data, right?
Oh. Oh, so that means I need to save this somewhere.
Um,
Yeah, like let vol value this, um, and then in, and
uh-huh.
then another parenthesis, then close
I don't think you would need the parentheses there in this case.
value. There, something like this.
And and
Oh, there's another and going on there. Yeah, like this.
beautiful.
One, yeah. I don't know if I would use you would I would say beautiful, but definitely something.
Definitely
Uh,
something special. Uh,
okay, that was fixed. Nice.
now we just
122.
have another 1,000 bugs.
Oh yeah,
Mm.
I'm not surprised. Why are you surprised? So
Yeah,
type
this
error.
hash table bullshit is will break. Don't worry. The typing.
Yeah, but look at there. Type error in function application. Function. Word
Oh,
8 word list.
same garbage as I said. You're trying to concat a word 8 list. You need to concat a word 8 vector list.
So
Line 122.
true. This one.
Yeah, same garbage we did on 124.
Okay. 8.
Put on a happy face. Lemos. Put on a happy face.
uh,
Yeah.
there. There.
I didn't need the parentheses there, right? But that's okay.
I think I'm gonna remove them. I don't want to compete with Lisp. I'm fine. There. What's next? Whoa! Much less errors. Okay. Pattern matching
Many.
an expression having compatible types. Pattern. This expression.
123. The return of the function signature you did not change on the line
That is
1.104.
true. That is true.
That's not
Int.
how you do a tuple.
Oh, I forgot. It's
It's
this.
a yeah star.
Next. Which by the way,
120.
which by the way, they will change this in Haskell. It will not be parentheses with commas anymore.
It's not a hash array concat. It's word 8 vector dot concat.
Word 8 vector. That's correct. Oops.
Wordy. 132.
132. And that this is a typo. 136. Is this?
No, it should be like that.
Uh,
Oh, I know. It's C's. I think
so
dot C's.
sys.
File C's. Sorry, file C's. Like on line 141. No, it's another module.
Oh, this. Not yet.
Is it?
It's still the same thing. It's saying type error function.
Okay,
Oh,
but now
it's a
it's not the
position.
function.
It's yeah, that's better. But this is a position.int, and we want just an int. So how we can we get rid of the position?
I remember. I remember being able to do that, but
We can check the source code. That's fine.
position.int to what the heck? Why encapsulate a position, man? Oh, probably because they do checks on
Yeah,
it
probably.
being positive and such.
Where is the here? So here's the thing.
Actually, I
Position.int.
think I think you better search in the entire thing because position. I think it's a shared garbage.
Oh. So you think position it's a shared thing.
Garbaggio.
Garbaggio.
uh,
Delicacy.
so we want position. Cool.
Did you find
There's
it?
no.
Oh, there's a module called position on Poly.
Where? It's not here.
Looking at their garbage, like the
Is there like a base prelude?
and they're saying, well, it's looking at their page, it's on the basis, yes.
Bases. Is there a base thing?
Oh, this should be it.
Where?
Well, this directory you're looking at.
No, but it's not. There's no position.sml here.
Yeah, so it's probably a module inside of another trash. Search on the search or jump to up there.
Yeah, I already
Oh, but
did
you're
that.
not logged in. You're not logged in. GitHub won't tell you
Ah, okay. That's why it didn't work. Cool.
because it's proprietary garbage.
No, there's proprietary garbage that allows you to do that. That's fine.
Yes, but and just man, just go with the
that's
GNU.
the
Just go with the GNU, okay?
okay.
Look at the int if inf of infinity.
Int inf.
Up there.
Here. Um, position.
Search for
Position. No.
There's just this. Can you
Is that?
send me the link and log in?
Yes. Oops. There. Um, there. Position module SML. Poly. Poly.
Polly loves you, Lemus.
It better loves me, man. I spent a lot of time on it. Like when we're not doing this, when we're actually like going through the problem solving, it's actually pretty fun. I just don't understand why the state of this is this.
Oh, we can still rewrite this in Rust.
uh,
Uh,
it's not gonna tell me, man. There's no position, whatever.
Man, I'm really scavenging code. I feel like
Welcome. According to Marinho and
uh,
Zozin, we're doing it right because the
found
code
it.
is the best
It's on
documentation.
int. It's on int.
Int. Cool. Int.
What I mean, that was predictable, I guess, but
I have no idea. Position. Oh yeah. Large int.
funny.
And large int, can I
I think
extract?
it's Man, I think this is just a wrapper they overwrite because you can do type overwriting, right, with like where. So you can
Um.
include a module and do where blah blah blah
Oh.
is blah blah blah. You see? So you can search for
Oh,
where
to
this
int.
time.
To int. Is that what you want, friend?
I don't know.
Position to int.
I don't think it's on the position, but well,
Aren't
try.
they just like renaming the modules and everything is a large integer or whatever?
I hope so, but I don't know which one. But do it, man. Try. Okay. No, it doesn't
Yeah, but
matter.
this is
Try.
returning in. Uh, I don't have
Yeah, it's
faith
an
on it.
int. It's an int. It's the same thing as the int type. It's just leaving the
Oh,
module
it
int
changed crap. Wait. Structure does not match signature. Oh, it's because there is an A here and an A
identity.
here.
Yeah, you need
But
to return a word 8 vector. You're returning a word 8.
yeah.
So just put word 8 vector from list, and then you put that thing in the A, line 95. Put this in a list,
Put this in a list.
and then you put word 8 vector dot from list.
It's still complaining, but not in this module anymore. So there is somebody here expecting a signature that we're not fulfilling, apparently. Not
Does
here.
it tell the line? Yeah, I didn't see a line.
It's saying line 1, in fact.
What? Oh, on the tests. Oh,
Yeah.
I see. On the instantiation of the bookkeeper, we passed the hashable.
Yeah.
So the contract of the hashable is not it's not working because the hash encoder has different signature.
Yeah, whatever this
Oh,
is.
just type. Just put like word 8 on the
Where?
A on the hashable struct.
Hashable. Word 8.
Yeah, this is
Uh,
retarded. Just type it as hash. Like open close parentheses on the A and put dot colon hash. Yeah. What now?
Bookkeeper 95. This one, actually. It's saying that because this is a hash, it cannot be passed into here because this expects a word apparently.
What?
Yeah, it's
But this
complaining
is a
here.
word. Oh, word 8. Change to word 8. Line
Mm,
92.
oh, 8.
No, no. Word 8 is is the thing. Yeah,
This?
there. Yes. But then you'd need to change on line 97 as well and 96.
Um,
Yeah. And
96.
word from 8, yes.
This is
This.
a word 8, so this is still 4 bytes.
Mm-hmm.
Okay.
Finally,
Oh!
yeah.
Okay.
Finally.
Okay. This was apparently this works. Well, it type checks, which is something. Uh, so this is for the hash table encoder. This is for the
By the way, I
hash
need to
table
sleep because
encoder.
I have to
Now
wake
the
up early.
question is, this is actually also incorrect. This should be files table encoder. And then because we are grugs, we're gonna just copy paste this thing. And we're gonna change this to locations. Locations.
Although they're different.
Although they
Yeah.
are different. And then we're gonna change this guy to location list. And then we're gonna have to change everything else, and we're not gonna do that right now.
You're not a masochist.
I would say that the term masochist already went through the window a long time ago. For
The
all
No,
of
I
us,
doctrine back,
for
mean,
all of
back to
us.
mercy.
like I like the language, but I'll be honest here. I think in C we would have already done most of it.
Don't you think that most of the time we're still discussing the design, and that's why it takes more time?
Yeah, we do. That's true. But
Uh,
like this feedback loop of like going through the documentation all the time and trying to scavenge code, like this
Man,
part
but
sucks.
I don't know about you, but I think Marinho is a very wise guy. If he says it's the best documentation, what can I do? Right. What can I do? Tell me.
It cannot possibly be outdated, otherwise it wouldn't work, right?
Yeah, as jokes aside, I think you're right, Magito. But again, I still feel that I'm learning how to think in an ML way, a ML type of way, like with the modules and the functors and stuff. I'm learning, which is fun. So finish draft of server and start serialization of hash tables.
There's no equality of types in ML, right?
Depends what you call equality of types. If they are subtypes, yes.
No, no, no. If you have two types, can you compare them for equality?
But doesn't that
You
require
mean
types
the
to be values?
values? Yeah, if you compare the values, yes. If you compare the
No, but
types, no.
I think what Marinho is asking is kind of like types being values, just like in Zig or whatever.
If
Oh, you
that's the
need
case,
this, I guess, if you're into that.
Yeah, but I don't think that's the case at all in here.
no.
Uh,
Yeah, I figure not, but the thoughts passed through my mind and I had to confirm it.
okay, so what is the steps for next time? We're gonna in offline we should finish this implementation here of the locations, which should be very easy by the way. Then we should make the opposite, which is the deserialization, so the decoder of both also. And then with that done, what are we missing? I think I can do this offline, not this week because I have to finish writing my thing, but I can try to do the deserialization offline myself this weekend.
I'll see if I can work at the documentation some more.
That's good. So Magetta, do you have anything in on mind that you can have fun?
I can try to make I don't want to serialize the other thing. uh, I can try to make the simple flow of like writing based on that, like just to connect the pieces together.
Well, we did the right. Yeah, okay. We can do try to make a
By the way, we
pipeline.
should leave to dos of the decisions, right? We're taking.
But that's the purpose of that branch. The branch that that Marinho is working on. This is the to-dos.
Yeah, but like I'm talking also about the choices, right? We're taking. So in the future, we have it documented and we can say,
Oh yeah, that's much
yeah,
more scrollable. We should do that. Let's actually let's end the stream with that. So let's put the to-do at the end. Let's put a list of to-dos here.
like for example, what I said about the files, right? We should have some to
Why?
do with that.
ML people. Why?
Maybe there's maybe it's missing an end somewhere, or maybe the mode is just dumb. One or the other.
It can't be the end because it compiles.
Maybe there's trailing white space before and it's confusing the mode.
I'm just gonna go in the README. I don't care. So let's put here to-dos. Go on Magetta.
Hello, Nathan, by the way.
Finish
Folks, I need to sleep now. So
finish documentation of writing and reading. Magetta,
and
list to me the things that you said.
I said about the continuation of the file, right? The access of the file.
Access, implement,
Yeah, append only file garbage.
append only files. What else?
And the other thing is the
Finish serialization of hash tables and Merkle trees.
yeah write and read from these scheme buffers, right? In pieces, tiny buffers.
Write and read in pieces of data in buffers. What else do we need? What else do we need? We need to start implement storage system for Weka Tower. What else are we missing?
Oh, don't know.
Well,
More magic.
implement chunkable story, aka make a miracle. Okay, that's reasonable. I'm gonna work on the first. No, Marinho is gonna work on the first. I'm gonna work on the third. So I think Marinho, me, and then Magetta. Okay. Let's update README with to-dos.
Update readme with todos.
Yeah, I'm gonna finish the recording now also.